method is called quantization variation. That's also for quantization-aware training. And the idea here is to use certain criteria like quantization sensitivity, outliers in the distribution, and weight oscillations to use adaptive bit allocation. So that means that we can start moving from fixed bit to mixed bit quantization. So now I'd like to talk about a couple of our approaches. The first method that we used is called multi-step knowledge distillation. And this work done with Navin Ranjan, a PhD student in our program. So the idea here is that if we use a method to quantize full precision to very low precision, let's say 2 bits only, then this is a very abrupt transition, and the system will not be able to do a very good job taking the knowledge from 32-bit full precision down to only 2 bits. So the idea is maybe we can use some intermediate stages that we call quantized teacher assistants. So if we go from 32 bits to 8 bits, and from 8 bits to 4 bits, and from 4 bits to 2 bits, it's a much smoother process, so less information is lost, and we can do better. And then we can work with losses not only from one stage to the next, but also, let's say, from the 32 bits down to the 2 bits, and the 8 bits down to the 2 bits, and the 4 bits down to the 2 bits. And these losses are a combination of cross-entropy loss as well as KL divergence. So that's the idea of multi-step knowledge distillation. And it can be used with different methods. For example, it can be used with the LSQ that we saw earlier, the learn step quantization method. And this one is looking for a scaling factor in the quantization process that will give us an effective quantizer. But this one has been around for a while, since 2019, so it's not the best quantization method one can find. But it works with that, and it will do well. And it can also work with oscillation-free quantization, or OFQ. So I think we discussed that as well earlier, where we try to reduce the oscillations that LSQ generates. So if we look at some results, we have a couple of data sets, the ImageNet1K, which has 1,000 classes, and the AID, it's a remote sensing data set, and it's collected from Google Earth. It has 10,000 samples and 30 classes. So I think most people know about ImageNet, but AID is not quite as well known. But since we do quite a bit of work with remote sensing, this is an interesting data set for us. And this is the experimental setup. We have the multi-step knowledge distillation, and we looked at quantizing different layers. The QKV are matrices in the transformer architecture. We also looked at the attention and the linear projection, as well as the fully connected layers. And we used these two methods, LSQ and OFQ, that we talked about. Now, as far as the model of the transformer, we use the DITE, tiny, small, and baseline. Just some results here on ImageNet1K. We have the LSQ and then MSKD, multi-step knowledge distillation LSQ. You can see this is quite a bit of quantization down to 2 bits for the weights and activations. So this is fixed bit. So we went for 32 down to 2 bits. But if we do it progressively, we can do quite well, especially with LSQ, for example, we can go from 54 to 61%. If we use OFQ, there is a small improvement there as well. And similarly for AID, we can get some improvements using the multi-step knowledge distillation, and OFQ will give the better result between LSQ and OFQ. So this one was an experiment on knowledge distillation that helped us understand that we can recover some of the knowledge lost if we do very aggressive quantization from 32 bits down to 2 bits if we have some intermediate teaching assistants. And we can add 1 or 2. If we add more than 2 teaching assistants, we found in our experiments that it doesn't help too much. So I would say 1 may be the best trade-off between extra work that we have to do and the improvements in performance. Now, the next work that I would like to discuss is mixed precision quantization for vision transformers. And this one, we use something called layer relevance propagation, which is an explainability technique. So our method is called LRP-QVIT. This also works with Navin. So there are several advantages to using mixed precision quantization. With fixed bit precision, we uniformly set the quantization throughout the network. But we know that some parts of the network are more important than other parts of the network. So that means that we're not going to be optimal in terms of performance if we quantize everything uniformly. So what we want is to identify which layers or which parts within each of the layers are more important and give more precision to those critical parts. And then for the less important parts, we can afford to give lower precision. That's why we want to try mixed precision quantization. Now, how we can use that, there are different approaches. We can do some search-based methods or criterion-based methods. Some of them are computationally expensive, and some of them may be sort of looking for something without really knowing why. So what we wanted to do is develop an approach based on explainability. And we use a method that was developed for interpretability of visual attention and use the layer relevance propagation. What that does, it looks at gradients relevance scores to look at the contribution of each layer to the output of the model. So then in our work, what we do is we develop a new mixed precision framework for quantization of vision transformers. We use the LRP or layer relevance propagation. With this one, we compute the layer importance score for each layer, and then we use that as a guide to do the mixed bit allocation in different parts of the network. We also observe that there's a fair number of outliers if we look at the behavior of the distributions in some of the parameters. So if we clip those, we're going to do a lot better because we reduce the dynamic range without losing anything. And in our experiments, we found that this approach with a mixed bit quantization will do much better than fixed bit quantization. So this is a little bit of a diagram of how our approach works. What we have on the left side is the process to assign an importance score to each of the layers. So we have a way to assign a layer importance score for every part of the transformer network. Now, this we can do ahead of time. We don't do this at the end, but it will require some data that we can run through the network to be able to tell that using gradients as well as the layer score. Once we have that, then we will try to quantize the model with mixed precision. We'll have a target as far as mixed bit width goes. And then we're going to be able to allocate different bits to different parts of the network. So let's talk a little bit about layer-wise relevance propagation, which came out of this paper here. It was in CVPR 2021, Transformer Interpretability Beyond Attention Visualization. We calculate the gradients for each layer, and then we compute the relevance of each layer by looking at the classifier output, setting that to 1 and propagating it backward. So as we propagate that backward, we have different scores for different parts of the network. And if we run multiple samples, we're going to start to get a distribution of each part of the network. Now, if we have both positive and negative values, we clip the negative values and we only keep the positive. And then the layer relevance map is going to be a combination of the gradients and the relevance for each of the layers. Now, once we have that, and we run quite a few samples through, then we can take an average, and that will be the layer importance score. So that's what this formula here does. Essentially, it takes an average. Now, how many samples do we have to run? We have 50,000 samples we could run, but if we run only 256, we didn't see a very big difference. So we can run a fairly small numbers. They're randomly selected from our data set, in this case, ImageNet 1K, and we can get a good understanding of the layer importance score. Now, how does this look like? This is how it can look like. This is a heat map, essentially. On the bottom, we have the layers 1 through 12. And for every layer, we have different parts. We have the QKV matrices and projection, FC1, FC2, and so forth. And each of them will get a score. This will also be normalized so that the total score is 100% on all parts of the network. This particular result is for the diet small model, but we could do that for any model. And based on that, then, we can start to decide how to allocate bits to different parts of the network. So the projection layers have the highest scores, which means that they need higher precision. And also the first two blocks, the first two layers, you can see more red here in the first layer. So then we want to allocate more bits in the first layers and maybe fewer bits in the layers after that. So if we do this kind of bit allocation in 1 through 12, we decide to allocate 5 bits to block 1 and 2, and then to the not so important part of the network go down to 3 bits, and everything else gets 4 bits, so that at the end we have an average or 4 bits for the activation and 4 bits for the waits. We also looked at clip channel-wise quantization, and this is what I was referring to when I said there are certain spikes that are out of distribution. They look like outliers. So we could clip those outside 2 standard deviations. And this one also helped performance. And we tested that with a couple of data sets, the ImageNet1K for classification and the COCO data set for detection and instance segmentation. These are some results on the ImageNet1K classification. We have 2 models. One is just using the clipping that I mentioned with fixed bit, and the other one, the LRP-QVIT, uses the mixed bit allocation I described. And we have results for an average of 4 bits quantization or 6-bit quantization. Some of the methods are fixed, so here you see 4 for fixed bit, and then multi-precision is MP with an equivalent of 4 for the model size. And LRP-QV does the best, but CLR-QV, just with the clipping, does quite a bit better than, let's say, the REP-QVIT method, which is the one it is improving upon. So both techniques offer benefits, the clipping as well as the mixed bit based on their importance score. And this is a similar result for COCO. Here we used MAC-RCNN with a swing backbone, and then we quantized the swing transformer, again, using the clipping only as well as the mixed bit. And here are some of the results. Similar behavior in this case. So as far as our discussion here, we introduced a simple one, the clipping the channel-wise quantization, which removes outliers and improves performance. And then our bigger contribution was the LRP-QVIT using the layer importance score to assign different bits to different parts of the network. And we have another work which we just finished recently, and that one is called a mixed QVIT. So in this one, we use 2 criteria. In addition to the layer importance I talked about, we also use quantization sensitivity, and that makes the system more robust. But in the interest of time, I would just refer you to this paper, which is available on arXiv if you're interested in this work. And these are the references for the 3 topics. The 2 topics I discussed in more detail, and then mixed QVIT is using both layer importance and quantization sensitivity for mixed precision visual transformer quantization. And you can see that Navin Ranjan is the lead author on all these publications. So with that, thank you very much. I think I completed my time, and I can take some questions if there are any.
Thank you very much, sir. Yes.
Yeah, you're welcome.
You can come here. We have students in the classroom only, so there is some query. They may join from the same. Okay. You may introduce yourself, Arfan.
Good morning, sir. This is Afan.
Hello.
Hello, sir. So my question is, how does multi-step knowledge distillation enhance model performance over traditional distillation methods? I can repeat
Yeah,
it.
so in traditional distillation, you do it in one step. You go from high bit representation, 32 bits, let's say to 8 or 4 or even 2 bits. But if we go to ultra low bit quantization, like only 2 bits, then there is a lot of knowledge we have to distill from the big model down to the tiny model. And if we do it all in one step, it will not be as effective. That's why we do the multi-bit to have an intermediate teaching assistant so that the teaching assistant can learn better. So if it's 8-bit, can learn better than the 2-bit, and then it can help, along with the 32-bit, distill that knowledge down to 2 bits.
Yes, thank you, sir.
Yeah,
Yes.
sure.
Sir, I am Arjun, sir.
Hello.
Sir, my question is, how does 4-bit quantized QTA contribute to performance gains in MSKD?
There is a little bit of echo. Could you repeat your question, please?
So, like, how does 4-bit
Slowly. Yeah.
contribute to performance gains in MSKD?
How does the 4-bit you said?
Sir, for 4-bit.
It's about MSKD, right? The multi-step quantization, your question.
Yes.
And you were asking, how does the teaching assistant contribute, if I understand
Yes.
correctly, right? Yeah. So the teaching assistant has learned something from the big model, right? So the 32-bit model has the most knowledge. The 8-bit has sort of distilled some of that knowledge down to 8 bits. Maybe it did not learn some things, but we hope that it learned the most important information. Now, if we go to 2-bit, we want the 8-bit to distill to the 2-bit what it has learned. And at the same time, the 32-bit model, the bigger model, is also trying to distill. So they are both providing guidance to the 2-bit model, to the smaller model.
Yes.
So that's how it tries to learn.
Yes, sir. Thank you, sir.
Thank you, sir.
Yeah, you're welcome.
Yeah, if more students have queries, then we can share it with you later.
Yeah, of course.
Okay, so
Sir, now we can proceed with the felicitation of our saplings and our certificates, sir.
Sure, thank you.
Now I may request Nidhi ma'am to felicitate the sapling.
yeah, so this is a token of gratitude from our side. Sapling. And now I would like Mr. Arko to play the certificate that we are presenting. So we'll email the certificate later, sir. Thank you so much for joining us and for giving such an interesting informational talk. Thank you, sir.
Thank you for the invitation.
Thank you, sir.
I wish to all the students good luck with their studies.
It was a great privilege to welcome Dr. Andreas Savakis, sir, with us today. Thank you, sir.
Thanks.
Okay.
Bye-bye for now.
Seema Verma. Hello. Seema ma'am, are you here?
Yes, ma'am.
Yes. Hello ma'am. Actually, I saw you that you have joined us.
Yes, yes. So, will
Yes.
it take, ma'am, to start the session because I have some important
Sir,
meeting for 5 minutes.
yeah, I think the participants have already joined. So we may start the session. So I formally welcome you to the session, means paper presentation session 1 of the Venue 2 today. Okay, so authors, have you joined? Paper ID 231.
Yes.
Okay. So you may first switch on your camera and you should show your ID card.
Okay, sure. Just a second. A college iCard would work, right?
Yes, your ID card means any ID proof.
Okay.
And I would request all other authors to carry the ID card along with you so that it will not take much time.
So this is my.
You may proceed with the presentation.
Okay. Yeah. So good morning, everyone. It is an honor to be here today to present our research on evaluating deviations from factual accuracy in online news using natural language processing. So, with the rise of digital media, misinformation has become a growing concern today, influencing public opinions, politics, and even financial markets. Our study aims to address this issue by leveraging NLP techniques to assess the credibility of news articles. Internet is a vast source of information, but verifying its accuracy remains a challenge. In this study, we introduce a system that employs NLP models, particularly BERT embeddings, to evaluate the trustworthiness of news articles. We compare official sources and unofficial sources using cosine similarity and analyze deviations from the truth. Yeah. The digital revolution has democratized access to information, but it also has increased the spread of fake news, ranging from propaganda, clickbait, and completely fabricated stories. Misinformation has serious consequences, from affecting elections outcomes to misleading people in healthcare decisions. To combat this, our study proposes a NLP based approach to systematically assess online news. Yeah. Our methodology consists of three key phases. First, we collect news data from web scraping tools like Selenium. Next, we process the text using tokenization and word embeddings. In the assessment phase, we compute cosine similarity between official and unofficial sources, scoring the credibility of news articles. Finally, we conduct a sentiment and bias analysis using models like TextBlob, Divert to conduct a subjective or politically biased content. So there are three main phases in our proposed methodology. First, we collect real time. First is the input phase, where we collect real time news articles using web scraping techniques like Selenium. The text is first pre processed using tokenization and BERT embeddings to structure the data. Then we do a truth assessment where we compute cosine similarity between unofficial and their official counterparts. So, additionally, we introduce a consensus scoring which evaluates how similar or how different the articles are and how they really relate to each other. Then, in the sentiment and bias analysis phase, we analyze the subjectivity of articles using text block and then detect the political bias using DBERT, which is a political bias detection model. So, to implement the system, we our unofficial official sources include government reports or verified news outlets. So in this our system we have considered few official sources like the BCCI or the Investopedia. So yeah, in the results and discussions, we tested our model on two queries. First was a sports news event, in which first query that we gave was India wins World Cup. Our results show that sources like traditional sources had high truth values, whereas Reddit posts deviated significantly. Sentimental analysis revealed that most articles were neutral, with some showing positive or negative biases, so that we have represented in our results using the charts. And then our second query was a financial case news study. So in that we put a query to the system that Sony ends $10 billion merger with Z Entertainment. So on the basis of that we got the unofficial sources which we compared to Investopedia, which is an official source, and then on basis of that we have evaluated the results. So our study demonstrates that NLP models can effectively assess news credibility. So unlike traditional fact-checking approaches, our method does not require extensively labeled data sets. So by analyzing these factors, we try to mitigate misinformation risks. So the future work on this can be expanded to using multimedia verification like images and videos. So we from the images and videos we can extract the frames, and then on basis of that we can compare it with official sources to verify the misinformation. So these are the few references that we included in our study. Thank you.
Yes, ma'am.
So this
Ms. Pranita, can you tell me how much data set you have considered for this particular task?
sorry.
What is the size of the data set you have taken for the problem? You have taken some data set, huh?
Yeah, right.
So what is the size of that?
So our data set, firstly, for the unofficial sources, we have used web scraping. So when we provide a query to the system, so we get all the unofficial sources web scraped from the internet. And for the official sources, for now, we have used the BCCI website, which gives all the news articles regarding to the uh, query that we give.
Your references and chart during the year analysis of the result. You know, you just explain that particular chart because we have no any explanation for that.
Actually, your voice, I cannot hear it clearly.
Okay, okay. Is it fine now?
Yeah,
I have referred to a chart also in your PPT.
yeah. So, hello.
Yes, yes.
Yeah, now the voice is clear. Can you please?
Oh, okay. My question is, you have referred to one chart, and that was some no, like low edge and the higher edge. Just you need to explain that particular chart. You skipped that chart.
Okay, just a second. This chart?
No, next one. Graph. That was a graph.
Yeah.
Yes.
So this is basically the source index. So here on the x-axis we have the source index, which is the index of all the sources that we got from web scraping, and then this is the truth value. So when we compare the unofficial sources with the truth value, so how much is true or it relates with the official source. So that is, this is the line graph of that, and this is the number of articles per sentiment. So in the sources that we scraped, so how many articles give a neutral sentiment and how many articles give a positive and negative sentiment, that we had mentioned in
So,
the paper.
so Priyanka, you have used BERT algorithm for that, right?
Yeah.
So, and you have not compared this particular result with any other in the literature. That is a must one. You have just taken two case studies, but
Yeah.
it's a suggestion to you that it must be compared with some other algorithm also, so that you can show your result as it is better than the previous one.
Okay, that actually we had written in the paper, so yeah, correctly, I would have should have included that in this as well. Yeah.
Okay, Mr. Rao. Thank you.
Yeah.
Next speaker can start now.
Now I may request paper ID 271 to present paper. So can you just show for verification purpose?
Yeah, this is my ID card.
Yes. Yeah. Yes, sir. Thank you, sir, for showing that. You may now proceed, sir.
I hope my screen is visible. Could you please confirm?
Yes, sir, it's visible, sir.
Yeah.
Yes, you may proceed.
Yeah. So hello everyone. My name is Archit, and the title of our paper is Text Prep. We are preparing a Python library which automates the process of data pre-processing with regards to text-based data sets. So the other authors along with me are Kumar Sampul, Tanya Bajaj, A. Lakshanya, and R. Bharti, and we're all a part of the CSE department of PES University. Now, with the ongoing trend of digitalization, we are subjected to an enormous amount of text data. So the government records are being digitalized, the hospital records are being digitalized. So there can be n number of tasks that can be performed on those text data sets. But the common thread through all of those is pre-processing. So our Python library aims to automate that process. So that's what's given in the introduction slide. We provide a Python library which has certain modules based out of LLMs, which automate the standard task of data pre-processing. Now, if you go online, you might find certain other tools which do the same thing as well, but they are not. They are really specific to one particular task. You might not find all those multiple tasks in a single tool. Also, there's a factor of reliability that kicks in. You would not want to share your secure data onto some random website, right? So that's where you can import a Python library and perform all the computations on your own system. So in order to get to our problem statement, we performed a literature survey wherein we gauged through all the existing NLP-based pre-processing techniques and their limitations. And then we performed studies on all the pre-processing tasks. So basically tokenization, stop word removal, stemming, and lemmatization, which are standard through which are required for most of the data processing tasks. Now, we also went through NLTK's role and its limitations and the rise of LLMs for text pre-processing. Once we were done, we came to a methodology which was a Python-based text pre-processing class for NLP. Now, the models that we used were BERT, T5, Distal BERT, and Hugging Face transformers. And this basically supports a modular and scalable approach for text processing because the constraint of data set size has been removed as you're performing all the computations on your own system by just importing a library. So you don't have any constraint on the size of the data set. You can pick up a data set as big as possible. The processing time might differ, but ultimately the task will be performed. Now the architecture has two different models, a small model and a large model. So the small model runs for a fewer number of epochs and has lesser complications as opposed to the large model. The reason for providing this is to provide a trade-off between speed and accuracy. So the large model might be more accurate, but the small model is much more faster. So if the task is not that complicated, you can go ahead with the smaller model for a faster inference. But if the task requires a nuanced approach, you can go on with the larger model. And we also have dynamic model invocation for efficient processing. Now the task that we are doing is our grammar and spelling correction, and we have our own fine-tuned version of the T5, Google's T5 model for corrections. Then we're performing tokenization. We're using Distal BERT for that, and for sentiment analysis, we're using BERT. Named entity recognition is another important aspect of text-based data pre-processing. And summarization, again, we are using T5 for that. Another task that I think my teammates forgot to mention in the PPT is masking. Masking again plays an important role because whenever you are performing certain tasks, you would want certain entities to be masked. So we are performing two kinds of masking. One is a standardized masking of all the inappropriate terms that our sentiment analyzer finds through the text. And the other one is a user defined masking. So the user can define certain entities to be masked. Now, with regards to model selection, as I said before, you can select between the two models, small model and large model, to provide a trade-off between speed and accuracy. And then this being presented as a Python library enhances the scalability of this model. It can be used for n number of tasks in n number of systems without any constraint. And when we performed our task, we validated the same with the given metrics, and all of those fell in the acceptable range. Now, the results were evaluated on a TMDB movie dataset, which is a standard dataset for most data pre-processing tasks. We also performed analysis on Twitter and Reddit sentiment analysis, and the other metrics were also listed in the previous slide. Then we also performed a comparison with the legacy NLP models. So, yeah. So we performed a comparison with the legacy NLP methods, which rely on mechanical segmentation. Our approach uses context-sensitive tokenization for improved NLP tasks, which provides a higher accuracy in sentiment analysis and entity recognition. And the screenshot might be a little blurred, but these are the results we got. I hate this product gives a sentiment of negative. We have tokenized each sentence. Grammar correction, this is an sentence is changed to a. Then stop word removal, all the stop words are removed, like an and which are removed from this sentence. And named entity recognition works as well. So the conclusion is that text prep automates text pre-processing efficiently, and it enhances accuracy, reduces manual effort, improves NLP workflows, modular, scalable, and adaptable for diverse text pre-processing modules. And the future scope would be to extend functionality beyond pre-processing and to include, like, the models that we are using are LLM based models. So there are new advancements that come in every week or every month. So we would want to integrate the higher models in our higher modules in our library so that the efficiency is top notch. Thank you.
Mr. Archit, you have used some libraries to pre-process the data, right?
Yeah, ma'am. We have used
So
like
actually, Mr. Arjit, this is one and the same thing. Like if you are doing step by step using NLP basic functionalities, and when you are using those libraries, because those libraries are taking those particular things in the background. I mean, you have not designed any module to do it in automatic way, right? You
no,
have
ma'am.
some inbuilt libraries to automate this process.
No, no, ma'am. We're using LLMs. So basically, these large language models are so like Google T5 is a standard transformer architecture. On top of that standard architecture, we have built our own flows for it to perform specific to our purpose. We're not
Yes, you
using any
use.
pre-built Python library. We are creating our own Python library.
Fine, Mr. Archit, you have used LLM model. No? That is again, your BERT is, you can say that is again the category of that you are saying. And a digital BERT you are using for small model, because I think you are focusing on that particular small data for digital BERT. You know? So those are the same thing you are talking about it. You are again using inbuilt libraries, no? Ultimately.
Not exactly, ma'am. The libraries that I would not call them libraries. The modules that we're using, the transformer modules, they are standard open source transformer modules, and we are building on top of those modules. And the ultimate goal is to provide a one-step solution for all data pre-processing tasks through in a scalable manner. So let's say there are multiple tools on the internet which use those, let's say for text pre-processing, those transformer modules might have been used in multiple uh, online tools, but those tools are not reliable. So our solution provides a more reliable and a more scalable solution, so that you can just import that our Python library onto your own system and you can work around there itself.
And how you are checking that your accuracy of the output?
I displayed the metrics in our PPT as well, ma'am. The standard metrics such as the rogue score, bird score, we're using those metrics to validate our results.
You have evaluated that both the answers, your
Yeah,
model
both.
and that already.
Yeah, they're both mentioned in the paper.
Okay, thank you, Mr. Arch.
Thanks for that, ma'am.
Anyone in the audience has any questions? Thank you yourself. I would like to call paper ID. I would like to call paper ID 275.
May I request the next paper ID 275 to present it.
I hope I'm audible. Am I?
You are audible. Can you just show your ID card, sir?
Yeah.
Can you just keep it at a distance, sir, so it was not visible? Sir, can you just show your ID card again, sir? It was not visible at that time.
Is it visible now?
No, sir, your screen has been shared.
Okay.
Yes, sir. Thank you, sir. You may proceed now, sir.
So
As you all know, I'm Amrit Subramanian. I'm a student in Amrita Vishwavidyapeetham, Coimbatore. I'm here representing the presence of my co-authors, Omkareshwara Rao and Mr. Jitin, who's my assistant professor at Amrita School of AI. So today's topic is on the role of generative AI and application development in compatibility matching and mental health wellness. It's quite a long, title to like make it short and like give it in a crisp way. We are basically trying to make a socialization web application which will connect people to evict loneliness and create a good state of social circle so that the mental health is maintained in a proper way. So our application's name is Zeros, as you know. So paper ID is 275, and I'm Amrit Subramanian from Amrita Vishwavidyapeetham School of AI, Coimbatore. So yeah, firstly, let's understand the problem in a very simple way. So loneliness and mental health issues are, it's kind of rising because people struggle to find the right people to connect with. Usually back in the day when we didn't have digital devices, people had to communicate with each other to for basic means of survival. But as time elapsed, right now we are stuck to our mobile phones and other gadgets, which kind of forms a social bubble where we don't interact with people. Since our genetics have been trained on, communicating with people for a long time, like since back in the day, not communicating with people right now due to the advancements in technology is kind of creating a concept of illness called as loneliness. It's something new for us. It will take time for our body to evolve, our genetics to evolve. So because of which, like loneliness and mental health issues like depression and stuff have become prominent nowadays. So usually to evict loneliness and mental health wellness, people go for the so-called mental health chatbot and dating apps which exist on App Store and Play Stores and stuff. But it doesn't work really well because there are 2 points to like support the not working state of dating apps. One is they focus on superficial traits like appearance and hobbies. The other is they don't focus on deeper aspects such as personality, values, and behavior. So dating apps are technically into objectifying people and not matching people using the right metrics. So to address this issue and kind of bridge the gap between human existence and social life, we developed a dating app with a mental health wellness chatbot. So the whole application is altogether is called as Eros, and yeah, so that's technically the problem and the solution which we provide. So let's see the objectives of our application. So the research gap here is that um, you might have heard about LLMs, but they come under the sector of generative AI. So generative AI, it has a good understanding of natural language. People call it NLU, natural language understanding, but unfortunately, they are not capable enough to autonomously take decisions, and that's where the usage of agentic systems come in. The concept of role playing, delegation, task assignment, and a multi-agentic workflow where each and every agent communicate with each other like humans, in a startup who are working on a project. So stuff like that, it gives the exceptional decision making ability for an agentic system, or let's consider a black box called as AI. So how are we using it here? So essentially, agentic systems, or like the power of NLU has not been potentially used in larger dating apps like Tinder and Bumble to match people, to like provide meaningful connections and and there's a lot of reason behind it because like LLMs, as you know, is not stable, and we'll come to that later. But using generative AI, especially agentic systems, as a part of it, is super useful in matching people. Uh, because it doesn't focus on quantitative measures, rather it focuses on qualitative measures. As I told you, agentic systems replicate humans, so it's more towards quality than quantity. Like numbers aren't given that much of a consideration, but decisions are. So that's what agentic systems are about. And the novel thing here is that this approach has not been explored. The approach where agentic systems are used in mental health wellness to like connect or match people with the database of users that we have. So we are trying to focus on it, and our um, final goal is to basically evict loneliness and like create a stable environment for having a uh, maintaining a good mental health for people. So that's the whole idea here. Before jumping into the methodology part and our workflow diagrams, I would like to, um, like showcase two or three of the papers that we cited and we got a lot of inference from. The first is large language model empowered automated well agent. So this was written by Ove Sundal in 2024. So it basically says agents are good at rationalization of choices and decision making. So what is rationalization? It's a concept where agents can behave just like us as humans who can make quick decisions, like instantaneous decisions without reasoning much behind it. So people call it common sense. So that is an aspect in LLM agents. And the second paper which we referred to was converging paradigms and like the synergy of symbolic and connectionist AI and LLM powered autonomous agents. This basically elucidates you about the importance of role playing in agentic systems. Role playing is it's a simple concept where you in the prompt you say you are an expert research scientist or something. Your task is this, do this, and give an output to the next agent so that he can work on that. So that's how it works technically. And this basically says how can we orchestrate an agentic system where agents can communicate with each other. So yeah, that's what that paper discusses about. And then the last part is, since we are doing a loneliness um, elimination application, we have to like delve a bit deeper into the domain part, the core domain, that is mental health, wellness, and like psychology and stuff like that. So that's where loneliness in general population, a paper which um, reasons of the prevalence, the determinants of it, the relations between mental health and loneliness and stuff is discussed. And the not so cool thing that is that 17% of the general population experience loneliness, which creates a very big market for our application, so that we can make the world a better place for people in future. So let's see the workflow diagram. The application is quite complex, so we couldn't cover everything in the workflow diagram, but this is basically the architecture of it. So in the top left corner, if you could see my cursor, so that's where the user is. A user is could be a male or female. Right now, we don't have multiple genders except these two. So and then what they can do is they can like feed in their credentials like email, username, password. They can upload their profile picture, age, the department they are from, the academics they are in, and bio, which is very important because we are focusing more on rationalization than just matching users based on appearance. So bio, hobbies, and stuff is super important there. And then what we do is when the user registers to the application, we send an OTP via a platform called as Twilio to their message or email. They get that and they sign up. So then what happens is the data which they fed initially will be fed to REST APIs built on a popular framework in Python called as Fast API. So that will technically be binded with MongoDB's ORM, Object Relational Model. So where the user credentials are stored, then the user will be automatically logged in. So login or user authentication is a very important process, uh, especially in a domain where we are handling people's personal data. It's super important too. So we have to use a complex robust system like JWT, JavaScript Web Tokens, for authentication, along with a bit of encryption like SHA-256 and a bit of salting, so that will work like a charm. So that's what we are doing there. Then what we do is, once logged in, based on all the users we have in the application or in the database. We essentially store users in two databases. One is MongoDB, the NoSQL database, a document-based database for static data retrieval, and then the other is QDrent. It's a local vector-based database which is used for similarity retrieval. So we essentially use cosine similarity, but cosine similarity is basically finding the similarity between two vectors, the angle of difference, the angle of similarity between two vectors. So it's a very simple algorithm to rely upon. So we came up with a sophisticated approach using an agentic retrieval system, which I'll be explaining in future. So yeah, that's what QNet is about. So once we like make the recommendation, we use Langchain retrievers. So Langchain is basically a super popular framework for developing LLM based applications or generative AI based applications or agentic based applications. And the most important part here is Grok. So as an application, our main aim is to like put more focus on sustainability. And when the models are large, the models which we are using are Llama 3, Mistral 8B, and Gemma 2B. Gemma 2 7B. So these are very expensive to run. And when they run, they consume a lot of energy too. So when they consume a lot of energy, that's super bad for the environment because the carbon footprint is taking a big toll. So to avoid that, we are using a platform called as Grok, where the models are pre-hosted. So the cool thing about Grok is it runs on you know a specifically designed chip called as LPU, language processing units, which is like super different from CPUs and GPUs. So these LPUs are designed specifically to run large language models and autoregressive models. So they run it efficiently with a faster inference time. So faster the inference time, lower the energy consumed. Lower the energy consumed, better the sustainability, better the carbon footprint. So that's the essential idea here. So once we get the outputs, we give it to the user and check whether they want to like hit or smash. So that's the whole idea there. Then we have a chatbot called as Salis, which gives you emotional advice and relationship advice on how to uh, you know interact with people, interact with girls, or interact with opposite genders and stuff. For that, we are using a complex agentic workflow, which was built on Crew AI. We have a lot of um, alternatives here. It could be Crew AI, it could be LangGraph, it could be Beehive, it could be small agents by Hugging Face and stuff. But we went with Crew AI because it's easy to implement for a POC. But if we are going for a production level scale, we would essentially be going to LangGraph technically. Yeah. So before building any application, the data collection part is super important. Unfortunately, since we are doing a generative AI based application, data sets are not pre-made. So we had to synthesize our own data set. How did we do that? So we referred to all the books that I've shown, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, approximately 10 to 12 books on dating advisors and taking control of your life, like basically advices on how to have a good
Excuse
mental
me, sir.
state and stuff. Yeah.
Sorry for the interruption, sir. Like your time limit is exceeding. So wind
Okay,
it fast.
I'll try. Yeah, I'll try to wind it up in 3 minutes.
Yes, thank you,
So
sir.
we basically do that. We chunk paragraphs and convert it to Q&A pairs using, of course, like hosted LLMs on Grok, and then we use BG large embedding models and Llama 3.18B to convert the the chunks we have to vectors. So we are using two embedding models here because we want rationalization where the bias is reduced. If you just use one embedding model, it might be biased towards a particular concept. But when you use two or more embedding models, it's more general. So that's the whole idea here. This is called as ensemble scoring. Ensemble scoring as in like combining multiple scores, and this is basically the formula behind cosine similarity. As you know, we are taking cosine similarity because directions are interests oriented, so it's focused over the interests rather than magnitude. So else we would have gone with Manhattan distance and stuff, but we chose cosine similarity primarily because of this reason. Another important thing is we built a chatbot. So an agentic bot, let's not call it a chatbot in a simple way. So this is what it does basically. And so whenever you talk about agentic bots or chatbots, an important concept is memory. So memory management is LLMs are technically stateless. They can't remember what you spoke to it. So we have to have a cache or a memory system which will store your previous conversations and feed it to LLMs. Usually an array-based memory management system is used, but it's OFN to retrieve everything and compress it. To reduce the overheads involved in that, we went to a tree-based hierarchical aggregate tree based memory management system, which works like a binary tree, where all the nodes are leaf nodes. Then they are summarized to the root node. Then we basically traverse a single path. One node per level, so that reduces the complexity of retrieval from O of n to O of log n. So that's how we are making, and everything is covered too. So that's how we are making the memory management system like more optimized for this particular use case using HATs. So we are about to end. So the good thing about our thing is for the chatbot, we are using an agentic RAG system for providing a proper context to like provide answer questions that users ask regarding dating advices and relationship advices. So we have the query, we basically retrieve chunks, and then we use an agent to grade whether it's good or not, whether it's oriented or not. If it's oriented, then we give it for generation, and then it's compromised, not comprom, and then it's comprehensively handled to give a proper response. If it's not relevant, it's sent back. The query is rewritten and it's sent back again to retrieval so that a better chunk is retrieved. So that's the whole idea here. The first screen is basically done using Cosine similarity, which is semantic search, and then the second screen is about agentic filtration. As I was telling you about Grok, language processing units, they are built in a very systematic and robust way. It's like highly sophisticated. So if you could see, they are very different from GPUs because they move in a linear fashion. And as you know, autoregressive models move or inference in a linear fashion too, like in a parallel way. So this one is more optimized for inferencing LLMs and VLMs and stuff like that. So this won't be really good for training.
Can you just wind it more faster?
Yeah, sure. So this is not really good for training models because GPUs are efficient for it, but LPUs are good for inferencing part. That's where Grok comes in. So this is basically the output which we are expecting, the interface which we did. You have a sign up page and a profile page. We have more pages too, but I didn't have enough space to, like put it in the PPT. So yeah. And these are our results. So first part is about the inference time using Grok versus a normal NVIDIA GPU for inferencing LLMs. So if you see, higher the token count, um, uh, uh, higher the token count, higher the inference time for NVIDIA. That is the orange part. And then higher the token count, lower the inference speed for Grok. So that's how efficient it is. And to basically evaluate the responses of the RAG system or the chatbot or the agentic bot that we made and the matching system that we did, the matching algorithm, we use something called as RAGAS, which is relevance, factuality, coverage, and fluency metrics to evaluate how good the retrieval system is. And it's basically noted here, like a normal RAG, more the complex the query, like more the efficiency compared to, like normal systems that we have. So this is the last slide. So the limitations regarding the application which we made is agentic systems, which is kind of unstable at times because LLMs do hallucinate a lot and they consume a lot of energy too. So it's super expensive. Then using hats, the hierarchical tree, which I told you as a memory management tool, will consume a lot of space and compute as well. So it's kind of expensive too. And using multiple LLMs for generalization, as I told you, the ensemble, embedding and stuff, scoring and stuff, it's not super cool because different LLMs will have different opinions and it might contradict with each other. So another thing is a potential switch. The whole system of agentic era might fall down because Lani Chun from Meta released a new architecture called as JEPA, which is Joint Embedding Predictive Architecture. This doesn't work in an auto-regressive way. Rather, it tries to fill out the gaps and reason well. So it's more efficient and accurate. If this JEPA comes into play, then the whole use of agent systems might, like fade away. So that's the essential idea there. And yeah, so that's pretty much it. Thanks a lot for your time.
Mr. Amrit,
Yes, ma'am.
what about security of your system?
Oh, yeah. So I actually mentioned in the paper and I forgot to, do it, what is it, in the PPT. So essentially what we try to do is we align with the security standards given by the Indian Government Association for building applications which handle user data. So that's done by using a part of framework provided by MongoDB Atlas, which is a framework, which is a platform, a cloud-based platform which provides you just a single API call, which will like secure everything for you. And to add more security layers to that, we are using SHA-256 to hash it, and then we do a bit of salting that. So that's the whole idea. And also to access the application, we are using, as I told you, JWT, JavaScript Web Tokens, which work on a token-based verification system. So every 2 hours or 3 hours, the user has to re-enter the platform. So we make sure that potential, and we are also considering CSRF considerations. So everything is like dealt comprehensively to not leak data.
Okay, your app is working on text only, not on voice or facial.
So we are using VLMs, unbiased, not unbiased, like uncensored VLMs, provided on Hugging Face to analyze the user photo, user picture, and get a clear description of it. And then rest all is text based, ma'am. We didn't really find the need of using a voice based model like speech to text model right now, but in future it could be really helpful for visually impaired people, maybe.
Yes. Okay, thank you.
Yeah.
Does anyone in the audience have any questions or doubts? They can unmute themselves and they can ask.
Now I would like to call presenter from the paper ID 289 to present his or her paper.
Am I audible?
Yes, sir.
Is my ID card? Is it clear?
No, it's not clear, sir. Just 1 minute. Yes, sir. Thank you.
Yeah. I'll share my screen. My slides are visible? Hello? Hello?
Yes, sir. It's visible.
Okay. So, let's get started. Yeah, good morning everyone. I'm Harish Vijay. I'll be presenting on behalf of my co-authors on the topic exploring deep learning approaches for sleep apnea detection under the paper ID 289 in conference SPIN2025. Let's get into the problem statement. Sleep apnea is a prevalent disorder that causes repeated interruptions in breathing during sleep. Yeah, so how it happens is like when you're sleeping, there will be a sudden disturbance in the breath cycle. You'll thrive for oxygen and suddenly you'll be waking up and you'll feel like, okay, I was feeling thirsty or something, that's why I woke up and you'll sleep. But a long term will lead to serious issues. Motivation. So increasing accessibility of electrocardiography. So nowadays we have easily accessible to ECG signals. So what we have to do is we have deep learning models and feature engineering. So how we do is what it matters. So that's what motivated us to work on the feature engineering part and improving the current level of accuracy objective. So this study explores and develops deep learning models including LSTM, LSTM and CNN combination, and it achieved a great accuracy, way higher accuracy than the existing best performing models. So our contribution will be a comparative analysis on the three models, CNN, LSTM, and the combination of them. So we also developed a robust pre-processing pipeline, which I'll be explaining later in the slides. So these are the literature reviews which we have gone through, and these are the recent papers after 2020 and 2022. So they did use some machine learning models, and yeah, few did use deep learning too. Deep learning gave a good accuracy as compared to the SVM and other machine learning models, as you can see in the accuracy sensitivity. So our model has actually crossed the best accuracy, I mean, state of art model's accuracy and specificity. Yeah, it's a little bit, way a little bit down than the US model sensitivity. So the data set which we used. So we had 70 ECG data records. So each were of 4 hours long. So we had .dat file, .apnea, .qrs. So .apnea file, it annotates for every 60 seconds. For every 60 seconds of the data set, from each file, like each 4 hours file. So for every 60 seconds, each minute it is annotated as apnea or not apnea. And we did have QRS annotations. So we know QRS peaks, right? So every beginning of the QRS peaks will be added with the dot. So these are the pre-processing visualization. So we can see the red signal is the original signal given by them. We pre-process, that is, we use DOW4 or DB4 wavelet denoising. What we did is we did wavelet transform using DB4. So DB4 is the one, and the blue, you can see how it looks like. It looks very similar to the ECT signal. That's why we employed that for our case, our ECT case. So we converted, we set a threshold, and above those threshold points are removed, and we reconstructed using inverse transform. So why we remove the higher threshold area? So those are for the finer details where noises are highly placed. After denoising, we normalize to avoid the bias towards the high value. So you could see here the red dot is the QRS annotation which they have given, and we have gone plus or minus 100 milliseconds to find out the maximum peak, and that's represented with the blue dot. So that will be the QR peaks. So what features we have used is after pre-processing, you can see in the entire methodology, input is signal, denoise, and normalize. We have used RR interval and R peaks. R peaks are nothing but the blue dots which we have detected, and RR intervals are the successive distance or difference between the two R peaks. So after finding that, we have interpreted both R interval and R peaks to the same 4 hertz, and we have used 3 different models, and the best performing model architecture is displayed here, which are 2 convolution layer and max pooling layer. So we have used 1D CNN in this case. So as we have discussed the methodology, we move forward. These are the evaluation metrics which we have employed. Yeah, we all know this is a glimpse of it: accuracy, precision, recoverable sensitivity, and specificity score. So these are the results we got for our ROC curve, and the last plot, it did see some new kind of patterns in between the training. That's why it's more wobbling, and finally it had somehow managed to converge to lower loss. So these are the results which we got using our 3 different proposed methodologies, and then you can see our only CNN model has achieved a good score, a comparatively better score as compared to the other models. So our proposed methodology concludes that our CNN model performs better. So our conclusion and future work. So based on the reviewers' comments, and we didn't use a diverse dataset because we had only one physionet dataset. Even if we go to Kaggle and other papers, somehow it is linked with the same physionet at 70 ECG recordings. Either they have taken 35 from that or a subset of that, but still it was same as the physionet dataset. So we Amrita students had connections with Amrita Kochi Hospital. So we have requested them for the ECG analytics.
Excuse me, sir, you're not audible. So you're not audible? Yeah, right now.
When it was disconnected, can I start from there? My future works?
Yeah, you're connected. Yeah. Yes, sir.
Yeah. Was I audible when I was talking about these slides? Conclusion. May I continue?
Yes, sir.
Yeah. So the main feedback which we got is that we didn't use multiple diverse data sets. So the main reason is that whenever we tried to get the data set from different places, it was all linked to the same link. That is, it was all from the physionet data set. So it was just a subset of that which people have taken and kept. So what we did was we had connections with Amrita Kochi Hospital. We have asked doctors personally for the annotated data set via our dean. So they said they will be giving us the annotated data sets and other apnea events too. So our future work in the next paper we will be updating it with the other diverse data set and other apnea events too. This comes to the end of the presentation.
Mr. Arjun, how it enhances the feature extraction using your CNN system in your case?
So what features we have used is that R peaks and RR intervals. The first thing is we have seen people using R peaks, but RR interval plays a major role that was not used by many. Why? Because if you have difficulty in breathing, the difference between the two R peaks will be larger. So it will take more lag and more lag, the more interval it will be between R peaks. That is RR interval. So that's why we thought, why not we try using that, and that's how we keep.
How many layers you have considered for your system? How many layers you have considered for your CNN system for this particular?
It was just 2 layers. We used 1D CNN. Since 1D CNN is a little bit complex, we didn't go for multiple layers, but we just had 2 layers, but it did work with the 2 layers. So convolution layer 1, max pooling, convolution layer 2, max pooling, then followed by fully connected layers.
And how you handle the overfitting problem in your case?
So in our case, since the data set was large, we checked it. We divided what is that? So first, what we did was 70:30 was the ratio which we divided for train and test. So different combination we tested. First 30, the last 30 was tested first. Then we kept changing the test data and it didn't work. We checked the different data which we were not trained on, and also we did the hyperparameter tuning.
Okay, Mr. Harish.
Thank you.
If anyone in the audience has any questions, you may kindly unmute yourselves.
May I invite paper number 301 to present their paper?
Yeah, may I audible? May I audible?
So can you show your ID?
Is it visible?
Yes, sir, it's slowly getting so. Yes, sir. Thank you, sir.
Yeah. Is my screen is visible?
Yes, sir, it's visible, sir. You can share, sir.
Yeah. 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 Good morning, everyone. And my name is Kotnur Ramkumar. And first of all, thank you for giving me this
So your
opportunity.
screen is not visible, sir. Can you?
Not visible.
Yes.
Oh. No, it is visible.
Yes, sir, it's visible, sir. You may proceed, sir.
Yeah. 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 Good morning, everyone. I am Kotnur Ramkumar, and thank you for giving me this opportunity. First of all, here we are presenting our work titled called Sentiment Analysis of Social Media Posts to Natural Language Processing and Machine Learning Methods and SPIN2025. And firstly, I thank you to our co-authors, T. Deepak and Dr. A. Patnamurthy. Today, I will walk through our research and findings. So, this is the outline of our presentations today. Like we started introduction, literature review, methodology, and all, and data collection, training, results, and conclusion. So coming to the introduction of our research paper. So social media is exploding with information, lot of information. Like today world, we are using social media. So platforms like Twitter generate huge amount of opinions every day. Like analyzing the different opinions can help businesses and policymakers understand trends and make informed decisions. So our research focus on analyzing their opinions and decisions. So which will classify the comments into positive, negative, or neutral statements. And the challenge is that social media data is very noisy and unstructured. So we needed an effective method to extract meaningful insights. So coming to the literature review, so many researchers have attempted sentiment analysis using models such as SVM and assemble methods. So however, these approaches often face issues like low accuracy, high computational cost, and difficulties dealing with noisy data. And our work contributes by integrating the better sentiment analysis tool, where it is nothing but it was a predefined dictionary which contains the words predefinedly, and they also used the traditional machine learning model like SVM, decision tree, and random forest. And these combinations help us to achieve better accuracy and proportions. So coming to the methodology, so this was the flow diagram of our methodology. Forum reviews is nothing but the reviews which we collect from the any data like Twitter or YouTube like that, and synchronous sentiment in annotation is nothing but we will give the specific comment as positive negative by manually, and we after that we will clean the text word embedding and model analyzing. So our methodology involves several key steps. Like first we collected data from Twitter data, and then we reprocess the data by cleaning it. It removes noise, punctuation, and duplicate entries and tokenization the text. We also applied words. We also apply stemming and lemmonization to reduce the words to their basic form. And additionally, we generate a word cloud to visualize the words. Like we will have a repeating words in a sentence, like having, is like that. So in word cloud, what we will do means if is the turns around like 2 to 3 times, it will count as single word. And finally, we trained our machine learning models using Radar to assess sentiment labels and classify the fields. So this was about the collecting and pre-processing the data. And coming to the data collection and pre-processing, and our data comes from a Twitter sentiment data set, and we have used this Twitter data set in this project. And during pre-processing, we eliminated unwanted characters and duplicate entries to clean the data. So, and we broke the text into individual words and used the stemming lemmonization to simplify the word cloud visualization helps us to see which words are most common, giving us insights into overall sentiment trends. Coming to the model training and evaluation, we trained our model using multiple machine learning techniques over 10 epochs. With each epoch, we consist of 2075 steps. During training, the accuracy was improved from 40 to 90%, and loss was dropped significantly from 8.7 to 0.37%. The validation accuracy ranged from 76% to 80%, and which tells us how our model perform reliable on unseen data. And this improvement shows us our system learns effectively from the data, like from unstructured data. Coming to the results and discussion, our results indicate that our framework successfully classified the data comments into positive, negative, and neutral segments. And notably, the decision tree model performed very well, demonstrating strong adaptability. And the overall performance in terms of accuracy and efficiency confirms that our approach is both robust and practical for real-world applications, not only in any data set. These results suggest that our system can be effective tool for businesses and researchers which improve their business based on the feedback they receive from any other platform and all. So conclusion. So we conclude our presentation by our research demonstrates a successful method for sentiment analysis on Twitter, and our framework efficiently classifies the social media comments into 3 segments like positive, negative, and neutral. And this work as real world application in understanding public opinions and market trends. For future, we plan to explore deep learning methods such as transformer model like BERT, LSTM, and all. And we extend our approach to real-time analysis across multiple social media platforms and also real-time analysis across different platforms. Coming to the references, these are some key references that have influenced our research. And these include studies on various machine learning techniques and sentiment analysis techniques. I encourage you to review them for more detailed insights into the background of our work. Yeah, thank you for giving me this opportunity, and I appreciate the opportunity to share our work with you today. I am happy now to answer. Thank you.
Mr. Ramkumar, your accuracy of your system goes from 40% to 90%, right?
Yes, ma'am.
Which is the base model for that? 40% for which model?
Ma'am, the decision tree.
Decision tree. And yours is? How it is so much? I think you have used only 10 epochs, no? So maybe
Yes,
this may be due to overfitting of the system. 10 epochs are too less.
But we have reached up to 90%, so
Yes, that may
Yes.
be the reason of overfitting, I think. Because might be you have taken some biased data and due to that only your accuracy reached from 40% to 90%.
Yes, ma'am. We are doing it.
Mm. Okay. Okay, thank you.
Yeah, thank you.
If anyone in the audience has any questions, you may kindly unmute yourselves.
I would like to call paper ID 321 to present his or her paper.
Hello.
Yes, sir, you're audible.
Hello, everyone. Am I audible?
Yes, sir. Can you show your ID?
Oh. So, my ID is visible. Hello. Hello.
Yes, sir. Thank you. You may proceed.
Okay. Let me share my slides. My slide is visible.
Yes, sir.
Okay. So, hello everyone. Good morning. Myself Anand Kumar, and thank you for this opportunity. So, this we are here to present a paper on designing. We have designed a malaria detection system based on convolutional neural networks. So here are my co-authors like Kuldeep Verma, Harshvardhan Awasthi. So now, so we know that malaria has been a very big issue since long time. And if we look at the different regions of our earth, like if we look at the sub region of Africa, so according to World Health Organizations, we find that in according to their data based on 2022, so according to that 240 million people has been affected with malaria, and in the same data it has been claimed that around 6 lakhs people have lost their life. So they are in the market, malaria detection has been malaria issues has been solved, being solved, like many old methods are being used, and this required very skilled professionals in the to detect such and to cure such disease. So if we see from 2000 to 2022, even the improvement has been seen in this field, but even the some regions where the peoples are not able to well such facilities, they are not able to get over this disease. So we need to develop a model which can be very cost effective, and it will be easy for them to detect the malaria before any situations that can harm their life also. So we have tried to build a model so that it can be useful for them, and in very cost effective way. So this is our basically idea. Like we will make a model, we have made a model, and this in this, we will collect a blood smear image, and we will put that image, and basis of the trend trend we have trained the model, according to that it will understand and it will analyze the image, and it then according to that it will classify the image where that person has been infected or not infected. So this is what the idea. It is a binary classification model. So if we move forward, so we have collected our data from the available. The data is available on the Kaggle, which is it consists of total 27,558 images, and these images have been classified into two categories. 50% is image is infected, and 50% is image is uninfected. So that there would not be any chance of bias. So that data has been classified equally. So Like if I talk about the methodology, so you can see here, this is the architecture of our model. Like we have implemented total 18 layers. Like we here like implemented 18 layers with more pooling, more dropouts. Like we here try to extract the each features like age data, try to minimize and reduce the overfitting. So for that we have dropout, so should not be any complication and should not create any error in the giving results. So here we have also analyzed how our model perform in each epochs. So as you can see, like in epochs one, like we have calculated this like up to 13 like 13 epochs. So as you can see, at each epoch the loss was decreasing and accuracy were increasing. Similarly, the data set was split on the we have splitted the data set into three categories. Like 80% the data we kept here for the testing purpose, and then on the 20% data we have divided for the validation, and the like 80% data we kept for training, then 10% data for validation, and the other 10% data for the testing case. So on the basis of those 18% data, our model like see we can see that on the training data the model loss how it's actually performing, we can see here. And in the same way we were along with validating with all the 10% data. So according to like if we see at the epoch 13, like training data has given us accuracy of 94.33%. In the same way, the data which we have used for validation, which was it was close to the 93.58. So it was like, yeah, our model was performing quite good with all the available resources we have used. So some of the comparison we have devised from the earlier published paper. So if we look at here, like the such like one paper was published by Das and his co-authors in 2013. So in this method they have used SBM and Bayesian method, and but with using that method they have able to achieve accuracy up to 84%. Like similarly other authors have published, but their model some if you look at that, they other authors have used the method like they made the model very complex, and some had trained their model with a small data set. Like so, but we are
Yes,
like
sir.
hello.
I'm so sorry to interrupt due to time constraint. Can you wrap up?
Okay. Sorry. Yeah, I'll wrap up in 2-3 minutes. Okay. So, like our model, we can see like we were able to achieve accuracy up to 94.33% with the large data set. So these are the some performance analysis. Like if you look at these blue curve, like these were the training. These are the curves we obtained while training the model, and how our validation curve has gone through it, gone through that every data we with every epoch. So as we move to the epoch, we see that data started to get accuracy to the what we have trained the model on. In the similarly, the loss function here, it's showing how the validation and the training loss were decreasing. Now, we conclusion, if we look out, like what's the conclusion we conclude from this? So why it is important? Like see, like as I said, mentioned in the earlier, like it is very in this like very skilled professionals are required. So this model can be a substitute for that in those regions where people cannot afford such high skilled people. With so this can be and even this can produce a result in very fast way, like in within the small number of times they can get their result. So this is a good thing they can use. And other like that this model can be developed in other field also, like in the diagnosis of plants also, like whether they are infected or not, like in that case it can be developed. And what are the future work if I say so, like as I said that accuracy has been up to 94.33%, because now what it can be done, like other pre-trained model can be used, and it can be integrate like resonate and effective net, so accuracy can be enhanced more. But we have to due to the available and constrained computational power, we have focused on developing our own model from the scratch, and like so that we can maintain and use whatever the available resources we have. So uh, and these are the some papers we have gone through. So thank you for this chance.
Mr. Anand, you have compared your system with the previous one, and it is from the table we have shown that it is almost similar, like 0.94 and 0.9433. No, it's not
Yes,
increasing
ma'am.
accuracy for that.
Hello, ma'am.
Yes.
Yeah, this slide you were talking
Yes,
about,
yes,
right?
yes. Like in second, third row, na, it is 0.94, and before that,
Yes,
before earlier to this, it's fine. 99 is there, but for small data set, it is okay. But in third,
yes, ma'am.
in 2020, it is 0.94, and your system is showing 0.9433. It's not that achievement, you know.
Yes, ma'am, but actually, what's the problem with the third data set? Like, the person that Shekhar and his team were used so complex method that is not easy for any normal person, and any those regions where peoples are not that much resource efficient to develop that much with that much complexity. Even their models, they have integrated basic CNN, frozen CNN, fine-tuned CNN, and on the basis of three different integration they have tried to achieve this much only accuracy. But as I said, ma'am, like we can improve the accuracy in the future case, like if we use any pre-trained model like resonate effective effectiveness, so these models can be integrated, and because they are trained on the large data set, like we have trained on 27,500 image only, but these trained model pre-trained models have has gone through training through millions of data set, so their accuracy will be more than this. They can achieve more accuracy. So due to the limited resources, limited computational power of the devices, we have tried to prepare the data set in such a way that with those data set we can achieve up to this much accuracy. So this is what we have done.
Okay, Mr. Anand, thank you.
Thank you.
Anyone in the audience has any questions, you may kindly unmute yourselves. All right, that was the final paper presenter. I would like to thank each paper presenter who presented their paper on their hard work. It was really a fruitful experience.
Thank you, everyone.
I thank everyone who are present here, and I like to brief about Dr. Seema Verma ma'am. Dr. Seema Verma ma'am currently holds the position of professor and head in the Department of Computer Science and Engineering at Delhi Technical Campus, Greater Noida. With over 22 years of rich experience in academia and research, she attained her MTech from JC Bose University, Faridabad, when she achieved the prestigious distinction of being a gold medalist and is also a UGC NET qualified. Her academic journey culminated in a PhD from Thapa University, Patiala, awarded in 2015. Dr. Verma has made significant academic contributions through numerous publications, 5 patents, and a Best Paper Award. She has organized and convened national and international conferences and served as an editor and speaker for several academic works. Dr. Verma is an active member of the IEEE Society and a life member of ISTE Society. Her research interests encompass artificial intelligence, machine learning, and information security.
Thank you.
Yes, ma'am. Like we request Arco to present the sapling. I may request Dr. Nidhi Gaur to present the sapling to Dr. Seema.
So I would request Arco to play the certificate of the ma'am. Thank you so much for joining us and for heading the session, leading the session. Thank you, ma'am.
Thank you so much, ma'am. Your presence really lifted the entire session's experience.
Thank you.
Ma'am, with your permission, can we close this session?
Oh, yes, sure. We
Yes.
are just formally
Yes. Thank
closing
you.
it. Thank you.
Thank you. Thank you for being part of SPIN 2025. We will resume with the next session at 11:45. And all those paper ID certificates will be mailed within
by next week. So it would take a week's time to send the certificates. In the meantime, you may also be required or you will be asked for the copyright documents. So provide that. Thank you for joining us.
I also wish to extend a warm welcome to all the delegates and the paper presenters present here. It is an honor to welcome Dr. Ahmed, a distinguished expert in wireless sensor network, the Internet of Things, structural health monitoring, and VLSI design. I would like to invite Dr. Nidhi Gaur to present a sapling to Dr. Ahmed. Dr. Ahmed earned his PhD in computer engineering from the University of Louisiana at Lafayette and began his career at IBM Semiconductor Research and Development Center. He later transitioned to academia, where he is now an associate professor of computer engineering at the Central Michigan University. A senior member of IEEE, Dr. Ahmed has made significant contribution to distributed computing, low power embedded system, digital signal processing, and robotics. He has authored 2 books and over 80 research publications, and he has played a key role in the major IEEE conferences, serving as a technical program chair, finance chair, and publicity chair for events such as IEEE, WFIoT, ICASSP, MWSCAS, and SIPs. Beyond research, he has delivered keynote speeches, tutorials, and short courses worldwide. Sharing his expertise in IoT and emerging technologies, he also serves as the IEEE Northeast Michigan Section Chair and a member of the IEEE SPS IoT's Special Interest Group. With extensive experience in both industry and academia, Dr. Ahmed continues to shape the future of IoT, embedded system, and signal processing. Please join me in welcoming Dr. Ahmed. Welcome once again, sir. We are honored to have you grace SPIN 2025. Now, I would request Dr. Ahmed to present his topic, Build Your Own IoT Architecture.
Hello, everyone. This is Ahmed. you pay for the physician, medicine, and many things. So, and imagine if every single family save one diaper per day, how much money we can save and how much energy we can save. It's not only about money as well, because we need to have a green environment. So saving diapers, that mean you save oil used for transportation, for manufacturing itself, and even the diaper itself, it takes time to recycle it. So it's a win-win solution. So anything could be connected to internet. There is no limit for things. So everything is connected, and we start to see this for everywhere. We can see smart home, smart car, smart city, smart TV, smart phone. Everything is smart right now. Even at home will be connected. Our home is equipped with many sensors that can save energy, can make our life much easier. And not only homes, city also will be connected. Everything will be connected together in order also to make our life easier. And even the world will be connected. Not only this, we also will be connected with things in order to check, for example, like if you are running, and you can check your heart rate, you can check how many miles you ran, and many other things, and you can upload all of this information to internet and use it later. So everything now is smart. But smart in Internet of Things, it has a meaning, different meaning, not the exactly meaning of smart, because for a certain extent, yeah, Internet of Things itself, it's not smart, but we can add some feature like artificial intelligence, some other algorithm to make it smart. But IoT by itself, it cannot be smart by itself, because smart means that you analyze data and take decision even without any previous knowledge about what's going on. But anyway, it's smart in IoT. When we call a device a smart device, that means it's connected to internet. That doesn't mean that the device itself it's smart, but the device itself has a capability to connect to internet and then use some algorithm, some other software to take a smart decision or to make it smarter. But when I have a smartphone, that doesn't mean that the phone itself is smart, but it has some capability to connect to internet and then make it smart. So the need to connect our asset came from us. Usually, when we wake up in the morning, we have a lot of questions. We ask ourselves, am I healthy? When is my next bus? Where can I park my car? Can I reduce my electricity bill? And many things. So, and usually we don't want to worry about all of this. That's the question came, why we cannot make all of these things take care of themselves and take care of us, and we focus on only one thing. We just focus on my job. So to go to my job and do my job, and about my electricity bill, my health, my bus, my car and stuff, they can take care of themselves. That's why uh, we came up with Internet of Things, or the idea of Internet of Things. So what is the component for IoT in general? So the first component and main component in things themselves. So it could be a sensor or actuator, and also connectivity, how we can communicate things, how they can communicate with each others. We have many protocols or many modules for communication, Bluetooth, Zigbee, Wi-Fi, and many other things. And the third component is data, because again, we need to analyze the data, visualize the data, and then take action or take decision depending on data. And then analytics is the last component. So why IoT is at an inflection point? Because the hardware nowadays is very cheap. You can buy, for example, a Raspberry Pi with $40, for example, very cheap. And this Raspberry Pi is a very powerful computer. It has many capabilities, so you can use. And also connectivity is easy and plug and play. You can use it in any device, in any modules, and available and cheap as well. And development is easy. And the most important thing make it easy for us to have IoT is the Moore's law. That means that number of transistors are double every 18 months or 2 years. So that means all the devices or new devices has more capability than before. So what is the IoT vision? The vision for the IoT is to fuse the physical and digital world together in order to create a seamless network of billions of wireless objects. And these devices can be able to direct their transport, adapt to their respective environment, self-configure, self-maintain, self-repair themselves. So this is the main vision for IoT. And the IoT evolution started long time ago, since the pre-internet started with using SMS with our phone, and then we came up afterward with the Internet of Content by sending emails, sending some information, use the internet for entertainment. And then after a few years, we came up with Internet of Service, that we can use e-commerce and e-productivity. And recently, we start to have the social media and the Internet of People. We can use Facebook, Zoom, Skype, and many other things. All of this together lead to Internet of Things, which is machine-to-machine or thing-to-thing communication, and so on. So what is the IoT enablers? The first enabler for IoT is us as a consumer and producers. Because for human being, usually they're looking for new things, looking to improve their life. So we think about many application and many projects and ideas, and from this we can, we enable to have the IoT, and then other people start to think how to solve this problem. The second enabler is the smart devices itself. They are available and very cheap. Third enabler is a communication network. It's available, and you have many modules available in market with cheap price. You can use Wi-Fi, Bluetooth, Zigbee, and 3G, 4G, 5G, and even 6G in future, hopefully. The last enabler is the cloud computing platform. They are available right now, and even either for cheap price or sometimes for free. All of this together enable us to have IoT. So what is the IoT loop? This graph shows how the IoT is working. First, we sense the data or collect data, and then we communicate the data, aggregate data, store it on cloud or something like this, and then we start to process data, analyze data, visualize the data, and depend on this, we can take an action, and then again, sense again, and go to the same loop. So let's start to talk about each component by itself. We'll start with IoT sensor and actuators. And we start to see recently, in the last decades, we start to see a lot of sensors available in the market and very cheap price. Like, for example, 25 years ago, it was very hard to find a sensor for a humidity sensor or a temperature sensor available in market with available or cheap price. But now we have many sensors available in market with very cheap price, and even to connect it with Raspberry Pi or Arduino or any microcontrollers, it's easy to use it. The second thing we need to talk about to understand what's IoT, and I think also it's a good idea for you to think right now about a project. You can do it in your lab or at home or in your car or whatever. Because I will walk you through all the component and what is available in market, what you can do, what is the challenge and stuff. And even if you don't have a very solid background about engineering or hardware or something, you still can do it, because even young kids, they start now to play with these modules and stuff, and they can do some IoT projects. So it's not all about programming, coding and stuff. Even if you don't have that much experience about coding and hardware and software, you still can do something with IoT. So the deal is for you to think about a project you can do in future, and you can start from now to think about this project, and then I will explain everything here, and then you can pick what you can do, and you can understand more down the line. And hopefully by end of this presentation, you will be able to have enough data. You can start your own project. So as I said, we start to talk about sensors. So whatever project you can pick, you can think about what kind of sensor you can use. Is we have many sensors available in market. This is just few of them, but you can think about temperature sensor. You can think about relay. You can think about humidity sensor, 7-color flash, IR sensor, heartbeat sensor, and many things. But again, this is just few examples, and you can go and search for many other sensors depending on your own project. And if you cannot find the sensor, you can find a way how to get some idea how to collect data. This is again will depend on your project. After the sensors, you need to come up with some hardware or microcontroller or a module to collect the data from sensor and do some processing and send this data or push this data to the cloud. I'm showing you here a few examples of hardware, and this is some also other examples of hardware. But if you are a beginner and you would like to have something simple and easy, and you can find the code or all the software you need, you can go either by Raspberry Pi or Arduino. Also BeagleBone or Intel Galileo. These four are easy enough for someone who want to start to do some IoT project. So after you pick your sensors, you need to pick your hardware, which you will connect your sensors. And again, you can check also, because some sensors, they are very compatible, and you can find all the software and stuff with one of these modules. You can check, for example, Raspberry Pi, and when you check Raspberry Pi, it can, or the sensor itself, it can tell you it's compatible with which module is compatible with which sensor. So when you pick your sensor, you can pick the hardware, which make your life easier. So when you connect them, it's easy. You don't have to do that much work to push the data to internet. But again, these are a few examples here for some hardware you can start with. But in order to pick your right hardware, also you need to have some criteria to the criteria to use this hardware. The first one is the size, how big the size of your device, the final device, how much power you can consume, because if it's you don't have if you don't have a source of power and you will have a battery, so you need to think about how much power it will consume and how much time the battery will last. So this is also one issue you need to think about. The interface with the sensors, as I said, you need to think about it. Security, is this module has security or not, or your project needs security or not? Cost, how much it will cost you, depend on your budget and your project, and many things. So you need to think about all of this when you pick your hardware. So we finished talking about sensors and hardware, and the third part here is the IoT communication. So we have many communication protocols here. You can use it for your IoT, like Bluetooth, and Zigbee, Wi-Fi, LoRa, and the same story. When you try to do your project, you need to know how much, for example, for communication, how much data rate you would like to have, how much range you will use in your project. Like, for example, if you are using an application for agriculture, and this is you have like tens or hundreds of acres, you would like to do a project for IoT in this, so you need a very long range. This graph here shows you different protocols and for different ranges and different data rate. Depending on your application or project, you can pick the right one. Like, for example, as I said, for agriculture application, you can use for example, LoRa, because LoRa has a long range for communication. For example, if you use this graph, for example, if you have a very long range as well, you can use GSM, but the data rate is low. But if you would like have high data rate, you can go with WiMAX, with high range. If you have a very low range and very low data rate, you can use Zigbee or Bluetooth and so on. So this is again depend on what kind of application or project you do. It's also good to mention something here about 5G, because 5G actually came because of IoT. If you look here, the old version or the old 4G, for example, the latency was like 10 milliseconds, but 5G will be less than 1 millisecond. And the most important thing here is the connection density, because in future we will have many devices connected together, and in the same, like for example, in one room you could find 100 of smart devices. So this is a challenge for communication. Like for example, 4G, it can accommodate only 100,000 connection per kilometer square. But for 5G, you can have up to 1 million devices per kilometer square. And even in future, we need more. That's why we start to talk about 6G as well. So we need more speed, more connection density, and even for data traffic and data rates and spectrums. 5G it's more compatible with IoT, and even we need to improve this more. So we'll start to talk about 6G. After you can pick your communication protocol, there are some standards. Like, for example, if you're doing research or something like this, if you would like to do some simulation or some research, we have many protocols here for like, for example, the RPL or the 6LoWPAN and IPv4 and 6. All of this is infrastructure protocols we are using for IoT, and many other MQTT and stuff, many other IoT standards and protocols. You can also do some improvement or research points here for example, for routing protocols and how to send the data and fast and many things. So these protocols and standards for people who ever want to do some research, but if you do straightforward projects, you don't have to worry about all of this. If you would like to do simulation before you do the real project, there are some software. I will show you here only a few of them. Like for example, if you need to simulate what you are doing before you do it in physically. So this Kentucky software is a good to start to do some simulation, and it has some compatibility with some hardware platform, so you can because we have tiny OS, for example, you need to check which one you need to use, tiny OS or Kentucky, depend on the compatibility with the hardware you have or the microcontroller you have, because after you do simulation you can download your software or use the same simulation code to do the hardware. So TinyOS is another one for simulation. After you collect the data, you use the hardware, you need to push the data to a cloud platform. I also collected here some of the available cloud platform, which you will send your data over there, so you can do store the data, visualize the data, and analyze the data. So here you can have Google Cloud, Microsoft Azure, Zebra, ThingWorks, and many of them. Again, I'm just collecting here some of them. These also are some other IoT cloud platform. ThingSpeaks is one of most popular within our students here at Central Michigan University. They are using this a lot. Another platforms here, Tempo also is a good one, which is they give you free code, free tutorial about Pi and sensors and Arduino and stuff. And it's a very friendly platforms that you can use even without any knowledge or experience about coding or how to run the platform. So this is these are the available platform in the market that you can use in order to send your data. So again, this is the entire story. You start from sensor and then connect the sensor to hardware and use a communication protocol to communicate the things together, and then push the data to internet using one of these cloud platform, and now you have your own data on cloud, and then you can run some other software to take the decision. This is the story for the IoT. As I said, till now, the device or the project you are doing is not smart yet. This is an IoT device, but to make it smart, we need to think about implementing some artificial intelligence or something like this. And artificial intelligence, it's like the brain of the body. So now, after you do your project, you collect the data, push it to the cloud, and then you need to run some artificial intelligence algorithm in order to analyze, visualize, and take action and make your project smart. And artificial intelligence, it has many branches and many things here. Like for example, you can do deep learning, machine learning, and text to speech, and many things you can. I'm just get this graph here for you guys to understand if you have something related to artificial intelligence. So if you would like to do some research or some project, so you can connect or you can find a way to find an algorithm for artificial intelligence. Another thing also related to IoT, which is the blockchain. And blockchain also came because of IoT to secure, or the idea came after IoT, because in order to secure some transactions or something like this, we need some new mechanism, and that's why blockchain could help IoT as well in order to secure transactions and other things. something it's good to mention also to understand everything related to IoT. Like we can hear about some terminology about fudge and edge. Fog and edge computing. Um, from the name, you can find out fog computing is something in the middle because fog usually in the middle between clouds and Earth, for example. So if you do some competition, for example, if your project, if you need to do some competition or you need to do, you don't want to do all this smart algorithm stuff in the cloud, you can do it in between at the gateway. And if you do it in the gateway, we call this fog computing for IoT. But if you do it at the device itself, if you have a Pi and you connect some sensor and you don't want to send the data to the cloud in order to take the decision on cloud, so you can take the decision on the spot at the Pi level or at the sensor level. So we call this edge computing. So this is a difference here, edge, fog, and cloud computing. If you do the competition or take the decision at the hardware or the sensor level, we call this edge computing. If you take the decision at the gateway in between, for example, we call this fog computing. If you do or make the decision at the cloud, we call it cloud computing. Another thing also came with the Internet of Things, which is Industry 4. And because again we looking for autonomous factories and in future machines are communicating with each other and finish the work or finish the job by themselves. So this is also something good to mention. The IoT architecture in general, just to give you an idea, or to divide it in different levels so you can understand more how you can come up with your own project. So we came up with an architecture or general architecture for IoT in 4 different levels. The first level is sensing and identification. Second one is network construction. And third one in information processing, and the last one, which is integrated application. And again, this is one architecture, and you can find different architecture from different groups, different people, but this is the main, all of them are almost the same idea. What the IoT applications? Actually, we have a lot of applications for IoT. I'm just bringing here some of them, starting from consumer and home, also smart infrastructure, security and surveillance, transportations, industrial application, retail application, and healthcare application, agriculture application, and many things. So IoT start to be everywhere right now. So what is IoT opportunities? Actually, as I said, using some sensors and some processing unit or embedded processing unit with some connectivity, 3 of them, if you use some software, you can get many applications, many opportunities for IoT. You can do, as I said, smart health application, smart grid, smart home, smart parking, smart energy, and many other services. And I like this graph because it shows you how is or what is opportunity or what is IoT. So it's very simple: sensors and some microcontroller and some connectivity, and put them together with some software. You can do whatever you want. But again, life is not easy all the time. We have some challenges here for IoT because the first one as well here for big data. We have a lot of data nowadays we are collecting. Even like, for example, for your smartphone, you have close to 9 sensors and all of this sensor collecting data. And you can imagine like a full of 90% of all of the data in the world has been generated over only the last few years. And also, it is estimated by the IDC that this year, 2020, end of this year, we will have 45 zettabyte of data. 45 zettabyte means that 21 zeros, so it's a lot of data. So how we can handle this data, or not only about storage, because storage is not a problem, how we can understand the data, analyze the data, visualize the data, and take the action, and even filter the data, because some of this data is not true, or how we can get the false data, how we can get the right data and take the right decision. It's very challenging, because again, the traditional algorithm to do data processing or data analysis or something like this won't work with this, because it's huge number of data, huge amount of data, and you need to come up with a new algorithm, new mechanism in order to get the right decision. Another challenge here would be security. Because, for example, if you have an application for health, like, for example, a pacemaker in your heart, for example, and it's connected to internet, and it sends data to the cloud, and the cloud will run as a very smart algorithm in order to adjust your heart rate. And imagine if you are sleeping and your heart is connected to the cloud, and someone can hack the system and play with your heart rate and harm or maybe kill you. So this is dangerous. So we need to come up with some new security algorithm in order to fully secure all of these applications, so people can use it. Because right now, I don't think it's safe, or people will accept it to be fully connected to internet. Everything is connected to internet, especially for health application, unless we can come up with a very secure mechanism and assure them that they will be safe. No one will hack the system. No one will know about their own privacy or own data and stuff like this. So we need you also to come up with some new security algorithm and mechanism in order to make it more safe and secure. Another challenge is the bandwidth and power consumption. Again, the number of devices will increase dramatically in future, and the available bandwidth will be soared. So we need to come up with a new idea how to increase the bandwidth and how to reduce the power consumption. Networking will be a challenge, because when the number will increase, scalability will be an issue, and diversity as well, and also how to come up with a low power network will be a challenge. So this is also some area of research if you would like to dig more and find some new networking for IoT. Another challenge is the software. Like, for example, as I said, the Raspberry Pi or any of the hardware modules, when you connect your sensors and then run some mini algorithm, and even you can run some artificial intelligent algorithm and stuff, so you can find or end up with a code on your hardware with millions of lines. So how you can debug if there's something wrong, or when you download something here and there, and how to find the error and to fix it or debug your software, it's a challenge. It's not like before when we have a 1,000 line software or code. Oh wow, I have a long code, and it was hard to debug and trace problems and stuff like this. But in future, when we will connect many things, and we'll have a code or software with many modules and libraries and stuff, we need to come up with some new software which is easy to debug, easy to write, easy to use, and even easy for regular people to understand, because again, you will give this device or this application for regular people, so they need to deal with that. So we need to come up with new softwares and stuff in order to also make this IoT more relevant. Another challenge here is standardization. And standardization, because again, everything will be connected, and many devices will be connected together, and they need to have the same standardization in order for them to communicate with each other. They need to talk the same language. This is very important. Otherwise, when things if they don't have the same standard, so it will be hard to take the right decision. So standardization is very important, and we have many organization, they are working very hard to come up with some standardization for IoT, for communication, for hardware, for sensors, for many things. For example, IEEE, ISO, ITU, and they are working to come up with some standardization for future IoT. So again, the idea is all of us need to work hard to make our life easier and to save money, power, energy, and make a good environment for us. And we need again to work just to come up with some good applications for us. Like, for example, if you see here in this picture, for future car will be fully autonomous car, and then you can sleep in your car, and then the car can go where, to maybe drop you off to your workplace and then go to parking lot, park itself, and stuff like this. But I don't think any one of us will trust the car right now to do something like this. So we need to work hard in order to make this available in near future. This is not an easy job to do it, because in order to sleep in your car, peace of mind, you need again to have a very secure system, so no one can kidnap you in your car and take you somewhere else, your car destination, to drop you off to your workplace. So you will find yourself in different destination. So you need to have a good security, reliable devices, and reliable sensors, and reliable hardware, so you can sleep peacefully in your car. You are sure that you will not be engaged in an accident, and many things. So all of us, I'm asking all of you to do more research, to do more project, to work more and more in order to make this car available in near future for us to use. By this, I'm concluding my lecture. Here is my contact information and my LinkedIn link is here as well. I like to be connected with you guys in near future. If you have any question, you can send me an email, or you can communicate with me on LinkedIn. I'll be happy to address your question. Thank you very much for listening, and you have a good day.
Thank you so much, sir, for such an informative session. Our students have some questions, but since we have scheduled paper presentations for now, so we will forward you the questions personally. Now, I invite Dr. Nidhi Gaur to present a certificate to Dr. Ahmed as a token of our appreciation.
Thank you very much, sir, for joining us and giving your informative talk here. So happy to see you in the next SPIN and some collaborations in future. Thanks.
Thank you for being a part of SPIN 2025, sir. It is a great privilege to have Dr. Aman Kataria with us today. I would like to invite Dr. Nidhi Gaur to present a sapling to Dr. Aman Kataria.
Hello, Dr. Aman.
Good afternoon, ma'am.
Good afternoon, sir.
Am I audible, ma'am?
To the conference SPIN 2025.
Thank
And
you, ma'am.
I'm happy to have you as the session chair. So we formally welcome you with a sapling. We have all the paper presenters here. They have already joined. So with your permission, can we start the session?
Yeah, sure, ma'am. Sure. Please proceed.
Before we start our session, I would like to brief about Dr. Aman. Dr. Aman Kataria is a faculty in the domain of electronics and communication at the University Center for Research and Development, Chandigarh University, Mohali, Punjab, India. He worked previously as an assistant professor at Amity Institute of Distance Technology, Amity University, Noida, Uttar Pradesh, India. He received the BTech degree in Electronics and Communication Engineering from the State Government Engineering Institute, Mellor Institute of Management and Information Technology, MIMIT, in 2010, and the master's and PhD degrees in Electronics and Instrumentation Control Engineering from the Thapar Institute of Engineering and Technology, Patiala, Punjab, India, in 2013 and 2020, respectively. He worked as a lecturer at the Electronics and Communication Department, National Institute of Technology, Hamirpur. He worked as a project associate with the CSIR, Central Scientific Instruments Organization, from August 2020 to 2022 at CSIO. He worked on Texas Instruments, in which he had the experience of projecting customized images on the screen of DMD, which assisted in the projection of vital information on the screen of head-up display to be deployed in fighter craft of Indian Air Force. He has contributed to various research activities by publishing papers in the various SCIE and Scopus Index journals and conference proceedings. He has published 4 international patents also. His research interests include machine learning, artificial intelligence, image processing, cyber physical systems, the Internet of Things, and soft computing. Welcome once again, sir.
Thank you, ma'am.
Sir, would you like to call upon the paper presenters or would you prefer if I did it?
No, you can proceed, ma'am.
All right. Now, I would like to call upon presenter of paper ID 82 to present his or her paper.
Good morning, ma'am. Thank you. Can I share my PPT?
Before presenting your paper, can you please show your ID?
Yes. It is actually, I have kept it on this. I have sent a bona fide. It's part of my PPT. If you allow me to share.
Yeah, you can share your screen, ma'am.
You can see the.
No, ma'am, we can't see your screen. Screen is shared. Yes, ma'am, your screen is visible now.
1 second, ma'am. Is it visible, ma'am?
Can you show your photo ID?
Ma'am, I had asked for bona fide. I don't have photo ID, but what I can show you.
Any photo. Any photo ID, Aadhaar card, ID card.
Like that. Okay. Can you see, ma'am?
No, ma'am, we can't see her.
You can just.
Ma'am, can you remove your background so it's visible? Yes, ma'am, now it's visible.
Okay.
Yes, ma'am. Thank you, ma'am. You may proceed. Before we begin, I would like all authors to keep your IDs with you
In
in advance before your presentation. Yes, ma'am, you may begin your presentation.
Yeah. I'm Komala Suarez. I'm research scholar. I'm working on this vehicular network under Madam Arundhati and Madam Mangala Patil in Bharati Vidyapeeth at Pune. Today I'm going to discuss about introduction, literature review, research gap, proposed methodology, result evaluation, conclusion. The topic is this: enhancing smart traffic management with IoT enabled onboard units in era of industry 4.0. I was just listening to Dr. Abdur. He was talking about embedded processing, connectivity, and sensing. I think this project involves all these things. Basically, the safety and speed while driving has become an important requirement in current scenario, but the road development is not as in pace with the number of vehicles. Besides that, we also have standalone automated vehicles. Despite cloud connected facility, it seems it's not helping much in avoiding accidents or traffic congestion or many other untoward incidents. So, considering this, we propose to collect a real data pertaining to the status of the driving from predefined and authenticated vehicles and process those data, derive appropriate control signals, and send to all the cars or vehicles around which are authenticated and which are suitable for this fleet of cars. As the diagram explains here, each of the car which are authenticated are connected to each other. So each of the cars with the OBU on it, it can communicate with the other cars as well as it can communicate with the Wi-Fi, which is Wi-Fi based cloud connection. For this, we have developed this small OBU which has Seed Studio XIO ESP32C3 as a microcontroller, and we have used only one sensor, that accelerometer, and with this one accelerometer we can get 8 different features, and these features are sent to the server through Wi-Fi. Likewise, all other cars can send these data, and at the server churns out the caution signals required, and it sends back to every OBU which is connected in the car. So this is how it has a V2X capability, also V2V communication possible with this OBU. And when we collect the data from all these OBUs, we use machine learning algorithm to churn out these caution signals. And we have seen in this project of mine, I have used 5 different models. Out of that, DT and SVM seem to be doing very well. So with this OBU, we can provide a low cost and low weight OBUs which can be mounted easily on the car. And this can also be connected to used by pedestrians and segways. In literature review, I have just gone through many papers right from 2021, 23, 2024. Most of the papers are literature review. Through this literature review, I have found the OBUs are constructed using ARM microcontroller development board and mini OBU technology this is the China made, and also there are many other Raspberry Pi ARM controller and so many other things. Sensor, they have used many sensors like inertial measurement unit, GPS module, and weather monitoring, air pollution unit, radiation detector, and so many other sensors. In this method, ARM controller in this 12 reference paper 12, they have used the method UI UX. They have taken the information from the OBU and they are connecting to the UI interface so that this UI UX interface on the mobile phone can help the driver. In this mini OBU developed by Xylong, in this they have considered the vehicle coordinate system conversion, and also they have used many classification. In another paper, they have used low power WAN based OBUs. They are claiming there is a LoRaWAN and narrowband IoTs are being used. In another paper, again, they have used the same thing. Now, in all these things, I have found the limitations are like costly, and each one is bulky, computational complex are more, and they have used accuracy, transmission delay, cost is more, computational overhead are considered as more. And in one of the paper, they have used mobile camera to access the sensing the environment. So what we found, like first of all, they are very bulky. It is difficult to mount on the dashboard or wherever. And in this UI UX interface, it is a disturbance for the driver. And also mobile camera, it is a bulky and costly affair. So considering this research gap, we have come up with the smaller OBUs, which has only accelerometer and Seed Studio microcontroller. Each of this OBU will be taking sensing the data like acceleration on all three axes, and it is giving whether it is stopping or moving depending upon the magnitude on all these axes. And then all these data will be sent on the cloud server. The cloud server right now I have used as a laptop, which is connected through Wi-Fi. And at the cloud server, the data is being collected and classified. Now, this is the actual photo of the microcontroller and the whole module. And this Seed Studio also, it operates at 160 megahertz. It has Bluetooth enability and low power. It has the so many other features, wherein important is it has 4 MB onboard flash memory, which is very much required for writing the program. And of course, it is very ultra small, and it has rich interfaces, serial interfaces. And this is another component that I have used, accelerometer, ADXL 3x5. It has 3-degree measurement. It can do X, Y, and Z. Next, once these modules are connected, kept or mounted on the car, and they start collecting the data, it starts collecting the data from the sensor, accelerometer, and sends it to the HTTP server. At HTTP server, all these, right now I have used 3 modules at the 3 different vehicles. I got the data, and these data are combined, and chunks of 10 rows are considered. This is because to eradicate the noise there. Then each one is labeled depending upon the OBUs they send with the label. The data which they send is labeled data. So those labels of all the 10 rows are again modified, and then we are churning out the caution messages. For this, we are using the machine learning model and classify the data, derive the caution signals, and then again the process starts. So it is observed that with the pre-processing of interpolation, what happens here is when we are combining the data from all 3 modules, it is found that the time and date timestamp doesn't match. So while matching the timestamp, we are like losing on the data. So those data which are lost are interpolated. With that interpolated data, the accuracy is found better. This is about V2V communication. Earlier, all this collecting the data from the sensor we are doing with the Arduino IDE itself. But here, when we come to V2V communication, Arduino IDE doesn't help anymore. So we have to use the expressive IoT development framework. In this, again, we have different Bluetooth modes we have. Out of that, BLE mesh seem to be very good, because in this BLE mesh mode, wherein we require a mesh provisioner and library. Yes.
So sorry to interrupt. Due to time constraint, can you wrap up?
Yes.
Thank you, ma'am.
This is the actual picture where I have mounted all the three modules and the area that I have gone through and collected the data. This is the picture of the data that we have done, and this is the result and evaluation. The first picture gives the original data of data that is collected, and last one, figure 10, shows the interpolated data. This is the performance metrics with the original data, wherein not getting so much of good classification, while after interpolation, the classification accuracy has increased to almost 99%. Now, in future work, along with this accelerometer, we can also add GPS and get the longitude and latitude. Upon this, again, we can classify the data and give the caution signals to all the other vehicles. And also, edge processing can be done. Right now, we have this Seed Studio, which is not very robust. Instead of this, if we use Raspberry Pi or any other higher end microcontroller, we can carry on with the edge computing. So the caution signal can be done very easily. And if we come to data privacy, the data privacy and sharing, it can be, right now there is no data privacy and sharing. Anybody can access the data. If we use federated computing techniques, we can have the data privacy. By incorporating this 5G, 6G, the latency can be improved. And also authentication and signing in can be also implemented to keep the intruders at a bay. These are the different reference paper I have referred. Yeah. Any questions? If there is. Yes, ma'am. Any questions?
Hello. Am I audible?
Yes.
Please explain me, are you transmitting any kind of data through mobile networks or any kind of wireless networks in your work?
Sir, yeah, from here, each one of this will be sitting on the cars.
Okay, okay.
So from Wi-Fi, we are not using any mobile app, but from this OBU itself, it has a Wi-Fi enabled Seed Studio. So it directly sends the data on server, sir.
And server is connected to?
Server is connected to Wi-Fi again. Actually, on the data sheet of the Google Sheet, I get the data directly using get data and send data. Those libraries are there in Arduino IDE.
Okay, so in some cases, if some data is missed or the data is not recorded. So
yes.
Are there any measures to perform the data imputation?
Yes, sir. Because of that, I'm using the interpolation. With this interpolation, whatever missed data is interpolated, sir. Actually, in the original data, the many data is missed at many time. I mean, because this takes the data every 1 second. So while combining the data from all other OBUs, we found there are many datas are being missed. So we interpolated and got the data.
Okay, so you have undoubtedly done the nice work. So my last question is, how are you handling the latency?
Yes, sir. Right now it is on the very initial stages. The latency is like very high. We have to do little modification, maybe like 6G or 5G, or we have to increase the latency. That is true.
Okay, thank you.
If anyone in the audience has any questions, you may kindly unmute yourselves.
Yes. Thank you.
Thank you. Now, I would like to call presenter from the paper ID 298 to present his or her paper.
Good afternoon, ma'am. Am I audible?
Yes, ma'am. Before we proceed, I would like to remind, keep your presentations of 10 minutes and show your ID card, please, before presenting.
Okay, ma'am. Ma'am, is it visible? This is my ID card.
Yes, ma'am. Just a minute. Thank you, ma'am. Now you may present.
Okay. Good afternoon to all. I am Sonam, a research scholar at USICT GGSIQ. Today I am going to present my paper titled Evaluating IoT Network
Excuse me,
Efficiency.
ma'am.
Yes, ma'am.
Your presentation is not visible.
Okay, ma'am. Just a minute. Ma'am, is it visible?
Yes, ma'am. You may begin.
Okay. My paper title is Evaluating IoT Network Efficiency through Seamless Communication with NetSIM. This is the index outline of my paper, which I am going to discuss further. Abstract, introduction, problem statement, proposed methodology, result, conclusion, and references. So this is the abstract of my paper. As we know, Internet of Things is the network of devices which share data between them via internet. And the main component of IoT is data routing. Routing is a process in which we share the data from source to destination. So in my paper, I have created two virtual networks using NetSim simulator for the simulation, and these networks use IoT sensor derived water quality and potability dataset, which I have accessed from Data Hub and Kaggle. And in first network, I have used 6 sensor nodes, a router, a gateway, and a server. And in another network, I have used 9 sensor nodes with same configuration. And to ensure smooth communication and effective data transfer, each sensor is set up to create data packets on a regular basis and send them to the server via gateway. As I have already discussed, what is IoT? IoT is a network of devices which share data between them via internet. And IoT connects different devices like washing machines, fans, televisions, refrigerators, etc. First, Kevin Ashton introduced the term Internet of Things in 1999. And there are many applications where IoT can be used. For example, healthcare, connected cars, military, environmental monitoring, and we can also use IoT in water quality monitoring also. So in my paper, basically I have used data set related to water quality monitoring. These are literature survey in first paper that titled an IoT-based framework of vehicle accident detection for smart city. In this paper, basically authors developed the framework using a IoT-based methodology and which uses sensors to detect vehicle accidents. And the proposed methodology can be used for smart cities for saving human lives. And my next paper is titled An Intelligent, Sustainable, Efficient Transmission Internet Protocol to Switch Between User UDP and TCP. And in this paper, authors proposed a new TCP IP green reliability technique for IoT. Basically, they proposed a theoretical methodology. They have not used any simulation in this paper. And the authors evaluated the suggested method using several quality of services like throughput, latency, and energy consumption. And the third paper is Siromi, that is secured encrypted routing of message in IoT. In this paper, the authors tackle the crucial issue of encryption and security in IoT networks, which is the main security issue in IoT. And in this paper, authors used Eclipse IDE and MySQL database for simulation, and they used AES
encryption method for encryption for securing routing process actually. And they have used MQTT protocol, which is used in IoT, and it is basically a publisher and subscriber based model in which publisher sends the data and to the broker, and broker finally sends the data to the subscriber based on the subscribed quantity or value. This is the problem statement of my paper. The primary objective was to transfer the collected data from source to destination node while comparing the throughput, packet transmission rates. And to accomplish this, I have used network simulator. Basically, in network simulator, we can create a network virtually and can study the behavior and performance of the network. And basically, in NetSim, there are many libraries like IoT, WSN, satellite communication network also. And in my paper, I have used data set from Data Hub and Kaggle. And through an analysis of important performance measures such as packet transmission, throughput, packet collision, the simulation results show how effective the routing is. These are the screenshots of the data sets. This is the proposed methodology. First, I have created two networks in NetSim simulator. In first network, I have used 6 sensors: water temperature, turbidity, transducer depth, wave height, wave period, battery life, and which link to a gateway. After that, a router is connected to the gateway, sending data to the server node. And the traffic produced by the sensors as it is transmitted to the server is shown by the green lines in the diagram. This is the diagram which I am talking about. So in this, the green lines are traffic generated by the sensors. And in this methodology, I have used COAP, that is Constrained Application Protocol, for communication. And basically, it is based on UDP protocol, which is connectionless protocol. And I have used this because it minimizes energy consumption, and it also supports reliability options. And in second network, I have I have used 9 sensors, that is pH, hardness, total solids, calorinics, sulfate, conductivity, organic carbon, trihalomethanes, and turbidity. And the performance of networks have been evaluated based on packet received, packet collided, packet generated. These are the networks I have created in NetSim simulator. These are the results. In figure 4, 2 charts in the images compare different applications based on throughput, packets generated, packets collided. In both charts, the number of packets received are low than the number of packets generated. So it indicates that packet loss is in transmission. And in left chart of figure 4 shows that throughput remains high across all applications despite various variations in packet loss. So by this figure, we can conclude that the system maintains a relatively stable data transmission, but there is a room for improvement in packet delivery and efficiency to minimize loss. And in figure 5, the chart shows the difference between packet transmitted, packet loss, and in right chart shows that for all applications the number of packets received is lower than the packets transmitted, and the majority of packets transmitted successfully are basically data packets, and control packets show a higher tendency to suffer from collision or error. So conclusion and future scope. We can use IoT in water quality monitoring. This research work assesses the effectiveness of IoT-based water quality monitoring networks by implementing a data transfer method using NetSim simulator. And I have used data sets from Data Hub and Kaggle and created 2 virtual networks. In first network, I have used 6 sensor nodes, and in second network, I have used 9 sensor nodes. And the efficiency of the routing approach in guaranteeing dependable data transmission was demonstrated by the comparative study of these 2 networks. and data was successfully sent to the server node via gateway and routed by the first network, which was monitoring 6 water quality metrics, and second network, which was monitoring 9 portability parameters. And in future scope, I will try to secure the routing process by adding a new encryption method in scope protocol, which is already built in NetSim simulator. These are the references of my paper. Thank you.
So, Miss Sonam,
Yes, sir.
so I can see in your work there is a transmission and receiving of data.
Yes, sir.
So, can you please explain me that how will you manage with the scenario where there is a high density wireless network, and how it will your NetSim will analyze and optimize the network throughput while minimizing the congestion and the packet loss, which will obviously take place.
Okay, sir. So basically at network layer, I have used AODV protocol, that is ad hoc on-demand distance vector routing, and we know that it basically handles easily dynamic networks. And in AODV, we maintain routing table on demand only. So AODV is better for dynamic networks.
Okay. So next, is your AOD able to mitigate the issues occurring due to adjacent channel interference or co-channel interference?
Yes, so basically there is no loop generation, but there is a disadvantage too. It require high bandwidth requirement.
Okay. Okay. Good. Thank you. We can move on to the next candidate.
Before we proceed, I would like paper ID 298 to switch on their camera.
Okay.
Just to check. All right. If anyone in the audience has any questions, you may kindly unmute yourselves. I believe the audience does not have any questions. So now I would like to call presenter from the paper ID 417 to present his or her paper. Before I begin, I would like to tell you that keep your presentation of 10 minutes. Also, please switch on your camera.
Is my screen is visible, ma'am?
Your screen is visible, but can you please switch on your camera? Yeah. All right, you may begin with your presentation.
Sure. Shall I proceed, ma'am?
Yes, ma'am, you may begin.
Okay. Whether my PPT slide is visible for you, ma'am?
Yes, ma'am, it is visible. You may begin.
Okay. So, So myself, Ten Muri, my paper ID is 417. So my paper title is A Heuristic Evaluation of Energy Saving Algorithm for 5G Wireless Communication Network. So this is the outline of my presentation. I'll start with the introduction, strategy of 5G technology, 5G requirements, motivation, literature review, learning-based algorithm, methodology and implementation, simulation results, and future trends and conclusion with respect to the references. So introduction. So as an enhancement of cellular networks, ma'am, I'm just getting this dialog box. How? Okay.
Yes, ma'am.
Okay. As an enhancement of cellular network, the future generation 5G network can be considered as a ultra high speed technology with a remarkable services such as high data rate, bandwidth usage and reliability for the ensuring quality of service. With respect to the data rates of about 20 gigabits per second based on the IMT 2020 requirement, and the latency of about 0.001% of 20 byte packet can fail to be delivered by 1 millisecond. So with respect to the low and mid band frequency will be about below 7 GHz and high band millimeter wave frequency of about 24 GHz. So these are some of the strategies of the 5G technology. In case of industry growth overview, about 9.98% of industry expansion in the year 2023. With respect to the patents and grants, about over 20,800 patents and 300 plus grants are there in the 5G network. With respect to the global footprint, in case of worldwide presence, it has a country hubs and the city hubs. So startup ecosystem examples are satellite-based maritime 5G, 5G routers and millimeter wave radar as well as beamforming. So 5G technology in India, in case of rural and remote areas, about 2,81,948 5G towers across the countries, and in the mobile companies like Samsung, Oppo, OnePlus, Vivo and Realme have introduced variety of 5G enabled mobile phones. So these are some of the requirements of 5G networks. So like mobile communication, energy efficiency, reliability, mobile volume data, latency as well as service deployment and connected devices. So 5G network with respect to the increased connectivity, efficiency and sustainability. So to achieve this, these are some of the factors such as device-to-device communication, multi-user MIMO, energy harvesting, ultra-dense network, mobile infrastructure sharing and beamforming. These are considered to be the high increased connectivity, efficiency and sustainability. So energy efficiency is the core of my paper. I have analyzed recent algorithms in case of energy efficiency with respect to the 5G network. These are the 4 important factors like deployment and planning, hardware solution, energy harvesting and transfer, resource allocation with respect to the green 5G network. So the motivation why I have chosen this particular energy efficiency as my topic is that because of the environmental and the economic impact with respect to build the green cellular network, with respect to 80% of total wireless network consumption can be reduced. So increasing the throughput and reducing the energy consumption is the deployment of large antenna arrays known as the large scale antenna system. So with respect to the large scale antenna system, to get the greener deployment with less number of base stations, so we can reduce our energy usage and the emissions so that we have a less negative impact on the network. So literature review. So here I have analyzed a recently implemented algorithm with respect to 5G network. So based on the energy efficiency, this is the core of my paper. So the first one is collaborative energy efficient routing algorithm or protocol for the sustainable communication in 5G and 6G wireless network. So here they have used the reinforcement learning based cluster formation algorithm. So the result shows that about 90% of throughput, 90% of energy consumption and 92% of transmission speed. So here the gap I have identified is that shortest route discovery they have analyzed. So going for the second one, towards sustainable 5G network, a proposed coordination solution for macro and pico cell to optimize energy efficiency. So here they have used the real coded genetic algorithm. The result shows that 23 megabits per second throughput while consuming the 1750.75 watt of energy. So here they have considered only the less number of pico station, that is considered as a gap for the energy, gap for the research work. And the third one, spectrum energy economic efficiency analysis of beyond 5G wireless communication system with separated indoor-outdoor scenario. So here they have used the heterogeneous cellular architecture that separates the indoor and outdoor scenario for the beyond 5G wireless communication system. So the result shows that energy efficiency curve converges when the SNR exceeds 25 dB. So the energy efficiency can be improved by 3.6% without wave and by 4.3 with wave for the two link simulation. So here they have considered only for the urban scenario. From future work, we can also consider for the another scenario. So the fourth one is nothing but AI assessed energy efficiency and intelligent routing for reconfigured wireless network. So here they have identified the algorithm, quick heuristic algorithm for energy efficient and intelligent routing. So the average request demands are greater than the 45. About 60% of links are active for the low load, and while 70% of links are turned for the higher loads. So the sleeping loads for is about 30 to 38. And here the average requests are very less when compared. So that may be increased. So going for the fifth one, so energy efficient joint user and power allocation in 5G millimeter wave network, a genetic algorithm based approach. So here a genetic algorithm based strategy is used. So result shows that 22.34% in case of residential area and 33.12% in case of office area. So the main gap here, the research gap I have identified is that it does not guarantee the quality of final solution with the optimal solution. So next is a secrecy aware deep reinforcement learning based energy efficient scheme for 5G hardness. So here secrecy aware energy efficient scheme for the two-tier heterogeneous network is utilized. So here the optimization problem occurs. So that may be considered for the further investigation. The seventh is discontinuous reception based energy efficient user association for 5G heterogeneous network. Here two-dimensional continuous time Markov chain and semi-Markov chain is considered. So here the performance indicators such as user performance parameters including the power saving, packet drop rate and end-to-end delay may be considered. Here high noise power is observed, so that may be reduced for the further future work. The eighth one, energy efficient virtual resource allocation of slice in vehicle assist beyond 5G network. Here, virtual resource allocation of slice in vehicle assist beyond 5G network with respect to slicing algorithm are used. So, if there is no suitable active node, the resource may be wasted. That may be considered for the further research work. And the last one is nothing but trading off the delay and the energy saving through advanced sleep mode in 5G RAN. So here they have used a advanced sleep mode and power saving of about 70% and reactivation delay of about 1.7 millisecond. So here the power saving percentage can be further improved for the future work. So here I have concentrated on a learning based terminal edge collaborative energy efficient routing algorithm. So in case of terminal edge collaborative task offloading scheme, according to the node's energy state change and efficiently consume the renewable energy distributed in the green rechargeable wireless sensor network. So the network topology optimization is first considered with respect to the energy efficient network topology by variable cycle block coordinate descent method based on the gritty strategy. So with respect to the deep reinforcement learning based on the dynamic baseline to understand the energy efficiency feedback law of the network topology optimization layer and rationally adjust the terminal edge collaborative task offloading. Yes, ma'am.
Sorry to interrupt. Due to time constraint, I would like to request kindly wind up.
Okay, ma'am. So this is a process of my algorithm. So there are four processes: initialization, transmission, and energy consumption. So this is a methodology. There are three simulation scenarios, and in that three scenarios, they have identified the result. So this is my result. I have analyzed three algorithm. In that three algorithm, I have shown that the learning based terminal edge collaborative energy efficiency have the highest lifetime with respect to number of nodes of 300 nodes. So these are the future trends. So maybe in future, software-defined radio system, machine learning, and artificial intelligence can be integrated, deploying different stopper in each ecosystem with a heterogeneous network. And agriculture sector can use beyond the capabilities of the 5G network. So conclusion, energy efficiency is an important factor in green cellular communication, and it helps in minimizing the environmental impact of cellular network. So learning-based algorithm can handle more user nodes and offer a longer lifeline. So improvement in the energy efficiency within wireless communication network. So in case of energy efficiency in wireless communication can help the minimizing the environmental impact of the network operations and support the climate conditions. So these are my references. Yes, thank you.
And Mohit?
Yes, sir.
So kindly explain me what kind of scalability, there are some scalability issues when you use your algorithm, when the number of connected devices are increased in a massive IoT deployment. So does it affect the performance of the algorithm? Can you explain?
So based upon the active nodes, we are going to measure the energy efficiency. So only for the active nodes, even if there is more number of demand over the network in particular time, the active node is considered as a energy consumption, sir. So sleeping node we are not going to consider. That will be in off condition only. With respect to base station, I'm just talking, sir.
So also explain me, your algorithm is meant to save the energy. Am I right?
Yes, sir. Yes, sir.
So will it compromise the network throughput for to save the energy, or signal strength, or overall quality of service? Will it be impacted?
Yes, sir. It will increase the throughput because we are going to save
when you're saving the energy, how the throughput can be increased? You have to increase the overall channel energy.
Okay, sir.
Okay. So
yes, sir.
I want to know, how will you manage the decreasing quality of service due to saving energy? Are you getting my point?
Yes, sir, I'm getting, sir. So I'm in the initial stage of this research work. I'm just understanding everything one by one. Maybe in future I'll do this, sir.
Sure.
Okay, sir.
Thank you.
If anyone in the audience has any questions, you may kindly unmute yourselves. All right, thank you, ma'am. Now I would like to call presenter from the paper ID 442 to present his or her paper. Miss Rachna Nair, are you here? Ma'am, can you please switch on your camera?
Yeah, I hope I'm audible now.
Yes,
my
ma'am.
camera is also switched on. The video is also clear, right?
Yes, ma'am.
Okay. This is my ID. I hope it is visible. The screen is being shared.
Yes, ma'am. And before you proceed, I would like to remind you, please keep the presentation of 10 minutes.
Okay.
Thank you, ma'am. You may begin.
Okay. Thank you. Okay. My paper ID is 442 and my paper title
Ma'am, your
is.
presentation is not visible.
Okay.
Ma'am, we can see your ID card, but your presentation is not visible.
Okay. Well, it is visible now.
Ma'am, it was visible before. Now we can see your laptop, but not your presentation. We can see your folder.
Okay. Well, I hope it is visible now.
No, ma'am. Ma'am, can you reshare?
Okay. What about now?
No, ma'am, still not visible. Ma'am, it's loading.
Yeah, it's okay.
Yes, ma'am,
now,
it's
yeah.
visible now.
Okay, fine. Thank you. Okay. Well, my paper ID is 442 and my paper title is Performance Analysis of Rate Diverse NCMA Technique Implementing MFMUD.
Ma'am, can you put it in slideshow mode so that's visible in full screen?
Okay. Okay, now it's visible?
Yes, ma'am. Thank you, ma'am.
Okay, fine. Okay, thank you. Well, my paper ID is 442 and my paper title is Performance Analysis of Rate Diverse NCMA Technique Implementing MFMUD Architecture for a Power Balance System. The authors of this paper are myself, Rachna B. Nair, and Dr. S. Kritika. I am presenting this paper for SPIN 2025 conference proceedings. Well, moving on to the abstract, rate diverse NCMA coded architecture with MFMUD is being proposed in this work. RD-NCMA MFMUD is being compared with that of the conventional method, which is the SIC PD-NOMA architecture. And RD-NCMA with MFMUD system is able to achieve a normalized BPSK packet of the order of 1.75. In comparison to that, SIC PD-NOMA is only able to achieve a normalized BPSK packet of the order of 0.22 at 11 dB SNR. And here in this work, MFMUD architecture, which is the decoder structure, and PNC decoder structures are being used to decode the native loan packets from the overlapped packets, and orthogonality is being implemented by the usage of the MFMUD architecture. Mutual information increases and also the correlation increases in the data packets, thereby which the reliability of the information is being considerably improved. And the near-end user is able to commensurate their respective SNR owing to good channel conditions in comparison to that of the weak users with the weak channel conditions or poor channel conditions. At 10 dB, 10 raised to minus 6 is the RD-NCMA with MFMUD architectures, that is error rate performance, in comparison to that of the far end user, which is only able to achieve a error rate performance of 10 raised to minus 4.9 at SNR of 10 dB. Whereas the normalized BPSK packet of the near end user incorporating RD-NCMA with MFMUD architecture at 10 dB is only about 1.6 in comparison to that of the far end user. It is able to achieve a normalized BPSK packet of the order of 0.4. And the literature survey, mainly 4 articles have been that is have played a nominal role in this paperwork. And first paper is actually being authored by L. Van B et al. And it is actually a survey on the non-orthogonal multiple access for 5G based systems. Here in this paper, the significance of the NOMA architecture pertaining to the cellular communication scenario is being discussed, and what are the needs and what are the challenges which is being imposed upon the PD NOMA architecture, which is a 5G based system, by the cellular communication current scenario is being accurately depicted. And the second paper is actually it is dealing with the power domain non-orthogonal multiple access scheme in 5G systems. What are the challenges being imposed upon the that is the PD NOMA? How it is able to achieve the rate performance? How it is able to achieve the error rate performance? The outage capacity, low outage capacity, etc. It is being dealt with, and how it is able to circumvent all these challenges is being widely discussed in this particular paper. And successive interference cancellation technique, which is the multi-user decoding architecture implemented as part of the PD NOMA architecture in order to segregate the intended user signal from the that is the overlapped packet or multi-user interfered packet. And these two papers are basically dealing with the power unbalanced scenario, wherein which there should be a large amount of power differences between the users within the that is within the cluster. Then the third and fourth papers are actually dealing with the practical based scenarios, where you're actually having the power balance scenarios. In power balance scenario, it is actually a depiction of the actual environment, where in which you are actually having users within the same cluster having more or less the same channel conditions, same power fractions being vested upon them, and because of which it is not possible to segregate these user signals based on the SIC implementation. So we have to go for some other techniques other than the SIC PD NOMA in order to have a reduced error rate performance and improvement in the information rate or the normalized BPSK packets. So in such cases, we are actually opting for the network coded multiple access scheme architecture. And in the third paper, that is authored by Pan H, Lu L and et al., they have actually concluded that on a concluding note, they have given that rate diverse and CMA architecture is supposed to be incorporated in a power balance system. And the fourth paper is actually dealing with the network coded multiple access scheme, where they are actually discussing in detail about the physical layer encoding, network layer encoding, and the architecture, like how we are able to decode the corresponding end user signal from the multiplex signal or the multi-user interfered signal. And here they're actually pointing out that in the research section that why does the PD NOMA architecture with SIC is failing in such scenarios. And in the introduction part, cellular communication, as we all know, it is actually gaining widespread popularity owing to large number of users opting for wireless as the mode of communication. NOMA is a 5G based system wherein which we are able to incorporate all the needs and demands of the existing systems. Like for instance, we have got the D2D communication, like actually in the keynote address also, Dr. Ahmed have actually pointed out about the IoT appliances and applications wherein which you require high data rate, even with this web conferencing or this webinars all requires high amount of data rate, which was not possible in the earlier decades. Now we are able to incorporate all this novelties in the made in the technological aspects of the 5G based systems. We have high data rate, we are able to achieve it, we are having lower error rate requirements, all that is being met with, and low latency, low outage probability, all that is being dealt with in the 5G based NOMA architecture, which is the non-orthogonal multiple access schemes. And PD NOMA architecture, as I've already told, it is actually dealing with the large power differences among the users. And one of the main criterion or the condition for PD NOMA to exist is that, like, where if we are able to incorporate it with a higher amount of efficiency, we require large power differences among the users which are being put into a cluster or grouped into a set. So PD NOMA SIC technique is the 5G based technique, and it is performing well in power unbalanced situations. And with the power balanced scenario, we have to actually opt for rate diverse NCMA technique. And the system model is actually, we have the IP layer, then we have the MAC layer encoding or the network layer encoding, then we have the physical layer encoding, and last we are actually formulating the physical layer packets. And the MAC layer encoding which I have incorporated in this work is Reed-Solomon encoder, and physical layer encoder which is being used in this work is the convolution encoder, and modulation technique for far end users we have to incorporate BPSK, and for the near end user we are supposed to incorporate QPSK. Orthogonal signaling waveforms is one of the novelty in this work which has actually been able to mitigate the multi-user interferences to a large extent, and with a very much reduced residual error we are able to extract out the desired user signal. An overlap packet of different users is being formed, as we can already see here in the physical layer packets are being actually formulated with all the different user signal being multiplexed together. At the receiver, whatever operations we have done at the transmitter, the reverse operation will be performed. Like for instance, from the physical layer packets, like you are actually forming the MAC layer encoded packet by the Viterbi decoder, and then that is the MAC layer encoded packet is actually being formulated into the original packets by means of the that is the decoder section. That is, we have the MAC layer decoder section, and owing to which all these different signals will be combined together to form the IPv4 jumbogram packets. And the MUD decoder, which is one of the novelty which is being introduced in this paper, is that that is, we are actually having the multiplex signal, where in which you have the linearly processed, linearly transformed, modulated signal, which has been orthogonal signaling waveforms is actually being incorporated, and this multiplex signal is actually being provided to the MUD decoder at the receiver structure, and wherein which you have the product integrators which are actually able to retrieve the desired user signal, and we are able to remove all the other users interfering signal components, and we are able to get the linearly transformed, that is modulated signal, and after which all the channel impairments which is being introduced by the transmission of the signal from the source endpoint to destination endpoint is actually being reduced to much greater extent by this linear transformation factor. And finally, we are actually demodulating the signal and retrieving each user's signal from this MUD matched filter bank structure. Physical layer decoding, Viterbi decoding is being implemented. MAC layer decoding, we are actually able to extract out the desired packet, native lawn packets from the overlap packets, and all these packets are going to be finally combined of a particular user by the that is to form the IPv4 jumbogram packets, which is of the size of 4 GB. Yeah.
Ma'am, you have 3 minutes to wrap up your.
Okay, fine. Yeah. And the research and discussion here, like we are actually comparing the throughput. Like already it has been discussed that rate diverse NCMA architecture is being incorporated, and this rate diverse NCMA architecture is being that is introduced for both far end and near end users. And we can see that we have actually got two far end users, which is user A and user B, and they are able to achieve a constant that is normalized throughput of the order of 0.4, and whereas the user C is able to achieve the upper bound limit of the QPSK modulation scheme of about 2. So that is an achievement there. And when we are comparing it with the conventional method, that is the conventional method, when we are comparing, that is a rate diverse NCMA architecture conventional method, we can see that that is at SNR of 14 dB, the near end user is actually having a normalized BPSK packet or normalized throughput of the order of 1.75. Error rate performance, we can see that 10 raised to minus 6 is being achieved at SNR of 10 dB for the near end user, and far end user is able to achieve the that is error rate performance of 10 raised to minus 4.9, and then it is around 10 raised to minus 2 for the near end user, and A and B is actually having 10 raised to minus 1.9 at SNR of 1 dB, not much differences over there. And mainly the basically after 5 dB or from 5 dB onwards, that is in the higher SNR regime, medium to high SNR regime, we are actually having a improvmental performance with respect to the error rate performance. And a concluding note, I would like to add that RDNCMA with MFMUD architecture is being proposed, and it is being able to achieve much better performance with that of the conventional method SIC PD-NOM architecture. Multi-user decoding complexity is very much reduced because we are incorporating the MFMUD matched filter MUD structure. So orthogonality is being achieved, orthogonal signaling waveform is being incorporated. We are able to reduce the interferences imposed upon the signal by other end users, and we are able to reuse this orthogonal signaling waveforms by other that is cluster users, so supported by sufficiently that there should be enough amount of distance between the these two clusters. and henceforth a reliable, efficient communication system, improvement in performance evaluation metrics such as the error rate, performance, and throughput is being achieved. And on a future scope, future work, we can actually implement cooperative relaying mechanism with the RDNCM MFMUD architecture, and we are able to achieve user fairness so that all the users are able to have a optimal value of error rate and as well as the normalized throughput or the normalized PPSK packet. And we can accordingly, depending upon the channel condition, we can actually select the modulation schemes. Higher cardinality order will be selected for the users with better channel condition. Low cardinality order will be selected for the users with weak channel conditions. These are the references. And thank you.
Okay, so Ms. Rachana, so you have presented your work on NCMA. So
Yes,
I want to ask, if I'm right, there is some additional processing time for encoding and decoding in NCMA. Am I right?
No, sir. Actually, I've done the simulation wise. It's not taking larger delay is not been is there. Even if I'm going for 255,233, that is encoder structure, Reed Solomon encoder structure, I'm able to achieve the results with optimal time, with low latency.
There will be additional processing time in real-time application. As far as simulation is concerned, you are absolutely
Yeah.
right.
Yes,
But
sir. Yes,
in
sir.
real-time application,
Yeah.
NCMA contributes the additional
Yeah.
coding and encoding time. Okay,
Yeah.
so which will lead to the performance degradation. Okay,
Yeah.
so how can this transmission latency can be improved? I'm
We
only
can
asking you
actually
theoretically.
yeah, we can actually incorporate this real-time application by using the that is USRP modules. We can actually incorporate and we can see the simulation within the indoor environment. So we can do with a smaller 100-meter distance. We can actually incorporate this and see the results.
Okay. So next question, my question is that in case of error propagation, where
Yes, sir.
erroneous packets are combined and decoded incorrectly, sometime it
Yes.
happens. Okay,
Yes, sir.
which leads to the performance degradation. Can you
Yes,
handle
sir.
this?
In NCMA architecture, like for instance, we are actually having a that is orthogonality is being incorporated. So that is one of the major punchline here, because the thing is that this particular we are able to, because error propagation mainly happens in PD norm architecture. The reason is that we are not able to remove the error propagation, which is being imposed upon the signal by other interfering signals. So it is actually propagating throughout. Like for instance, if you want to decode the near end user signal, and suppose if you have, let us say for instance, n equal to 3 itself, or if other users signals are not being properly decoded and there is an error propagation, it is naturally going to have an impact upon the near end user. So in this scheme, what happens here is that we are providing the orthogonal signaling waveforms are being introduced, and therefore we are able to completely eliminate out the other interfering signals. So therefore what happens is that we are able to just extract out the desired user signal with minimal error.
Okay, fine. Thank you.
Okay.
If anyone in the audience has any questions, you may kindly unmute yourselves. All right, now I would like to call presenter from the paper ID 490, present his or her paper.
Is my screen visible?
Yes, ma'am, your screen is visible. Before you begin, please keep your presentation of 10 minutes. All right, you may begin.
Okay, this is my ID.
Yes, ma'am.
So I guess my PPT is also visible right now.
Yes, ma'am. It's visible. You may begin.
So yeah, this research is done on hybrid modeling of slotted octagonal microstrip antenna
for X-band applications. The authors of this paper are myself, Pradipika, and Debanjali Sarkar and Parthapratim Shume. So moving to the introduction, as we all know, the demand for efficient and sustainable wireless communication system is driving significant impact in antenna technologies. Among various types of frequencies available, X-band become vital role due to its extensive use in satellite communication, radars, weather sensing, remote sensing, and military applications. X-band antennas are crucial for transmitting and receiving electromagnetic waves in these systems. Among different types of antennas available, microstrip antennas are plays a vital role because of its miniaturization, fabrication, and they are also affordable, like easy to manufacture, making them suitable for portable devices. The traditional antenna design methods, which typically rely on analytical and empirical approaches, fall short in addressing the complexities.
Excuse me, ma'am.
Yes.
Can you put your presentation on full screen, slideshow mode?
It's on full screen, I guess.
We can't see it on full screen.
It's on full screen.
Can you put it on the presentation mode?
Is it in full screen right now?
Ma'am, go to slideshow and you can put it on slideshow.
Is it getting in a slideshow mode right now?
It's okay, ma'am. You may continue.
So the traditional antenna designing methods, which typically rely on analytical and empirical approaches, fall short in addressing the complexities of modern RF environments, mainly for multi-parameter optimization. The machine learning offers a solution based on analyzing data, identifying patterns, and building predicting models. The GPR technology, Gaussian process regression, offers a probabilistic framework. Using Bayesian approach, GPR performs well even with the small data sets, which makes it suitable for scenarios for when the data collection is limited. It also excels at capturing relationships between design parameters and performance metrics. It is easier to implement and requires fewer trainable parameters. Coming to the design of hybrid modeling, the framework integrates forward and inverse modeling to effectively address high dimensional design problems more effectively than traditional standalone methods. This model is applied to design a compact, circularly polarized octagonal microstrip antenna tailored for X-band applications. To assess the model's accuracy and reliability, we conducted a detailed performance analyzing using two key parameters, APRE, average percentage relative error, which measures the accuracy of predicted outputs compared to the actual ones, and correlational coefficient, CC, to evaluate how closely the predicted results match the target response. In this work, an octagonal patch antenna with rectangular slots is designed for an X-band applications. The antenna is constructed on FO4 substrate with a dielectric constant of 4.4 and a loss tangent of 0.02. And compact dimensions of 28 mm of height, 28 mm of width, and 1.6 mm of height. The design and simulation are performed using HFSS. Initially, a simple octagonal patch resonating at 8.5 GHz with a return loss of minus 31 decibels is created. However, it shows the linear polarization with an axial ratio exceeding 35 decimals. To achieve circular polarization, slits are added on the patch on both sides of the feed line. After fine-tuning, the final dimensions include a substrate length and width of 28 mm, feed line length of 14 mm, and a feed line width of 1.5 mm. As we can see, the comparison with existing designs shows that the proposed antenna achieves a compact size while maintaining excellent performances, making it suitable for advanced X-band applications. In this study, a sensitivity analysis was performed to identify the impact of design parameters on antenna performances, especially bandwidth. Three significant parameters HP, WS1, and WS2 were identified as most significant effects on bandwidth. A parametric study was conducted by varying these three parameters individually while keeping the others two constant, generating a total 856 data patterns. The data sets containing design parameters and their corresponding reflection coefficient values was divided into 70% for training and 30% for testing. The hybrid model developed in this study predicts both design and electrical parameters using machine learning. The input data parameters are organized as HP, WS1, WS2, and F, and the electrical parameters is given as S11, which is a reflection coefficient. The model operates in two modes. When the mode is set to the 1, it acts as a forward module, generating electrical parameters when the input are given as a design parameters. And when the mode is set to 2, it acts as an inverse module, predicting the design parameters from the given electrical parameters. The model was trained using the generated data bits, achieving an average training error of 1.065% and a testing error of 1.926%, demonstrating high accuracy in both forward and inverse predictions. In this study, we explored the effectiveness of different machine learning models, GPR, Gaussian process regression, MLP, multi-layer perceptron, and SVR, support vector regression, for forward, inverse, and hybrid modeling. To evaluate their performance, we used two key matrices, APRE, which measures prediction accuracy, and correlational coefficient, which indicates how well the prediction aligns with the actual values. Our finding clearly shows that GPR outperforms MLP and SVR, achieving the lowest APRV and the highest CC across all models. This highlights its ability to accurately capture complex relationships within the datasets. The hybrid model, which combines both forward and inverse modeling, performed even better with GPR, demonstrating superior predictive accuracy. Overall, GPS's dynamic adaptability and correlation-based predictions make it most efficient model for this application, making it a strong choice for similar predictive modeling tasks. To assess the accuracy of the proposed GPR hybrid model, we tested it using a random input given as 10, 9.5, and 9. We have simulated an antenna by giving this input to the HFSS, and we got the simulated output as minus 27 gigahertz and with a respective 8.92 gigahertz of frequency. When these two inputs are given to the forward model, we got an output as minus 26 decibels and 8.9 gigahertz, which shows the most predicted value matches with the simulated value. To further validate the model, we used another test set. D is 10, 9.5, 8, 9, and 8.9, and E is given as minus 26 from the previous outputs. And the output we got from this is 10.6, 9.81, 8.8, and 8.74 respectively. We have given these parameters to HFSS to design an antenna. The resulting antenna achieved an axial ratio of 1.8 decibels, indicating it as a circular polarization. The surface current distribution, as we can see in the figure 5, reveals that the slit in the conductive path introduces a discontinuity, altering the current paths. The delay in the current flow along x-axis creates a 90 degrees phase shift to generate the circularly polarized waves. Finally, as we can see in the figure 6, the radiation pattern confirms that the right-handed circularly polarization dominates over the left-handed circularly polarization in both azimuthal and elevating radiating planes. To conclude, this study introduced a hybrid modeling framework using Gaussian process regression to effectively tackle high-dimensional antenna design challenges. By combining forward and inverse modeling, we achieve greater accuracy and efficiency compared to the traditional methods. We applied this framework to design a compact circularly polarized octagonal microstrip antenna for X-band applications. Performance analysis shows that the GPR outperformed MLP and SPR, achieving the lowest APRV and the highest CC values. This confirms its reliability in predicting and optimizing antenna performance. Overall, the proposed hybrid framework has proven to be a powerful and efficient tool for antenna design. Its ability to accurately capture complex relationships makes it a promising approach for future achievements in this field. Thank you.
Okay, so Pradipika,
Yes, sir.
are you a master student or a doctoral candidate?
I'm an pursuing BTech, undergraduate student.
Okay, undergraduate. Okay. So as you know that octagonal microscope antenna has a problem of limited gain. Are you aware of that? The
Sorry?
gain is limited.
Yeah.
The gain of the antenna is limited, has a lower gain as compared to some other antennas such as horn antenna or parabolic antennas. Are you aware of it?
Kind of.
Okay. And the bandwidth is also narrow.
Yes.
Okay. So due to its material, the substrate material, it is also encountering the surface wave losses. Am I right? So have you considered these disadvantages of the slotted octagonal microscope antenna in your study? Because it is more susceptible to environmental factors also. And it is very thin and lightweight due to its light. Although it has advantages that the design is lightweight and thin, but this is also true that it is not suitable for high power applications. So, have you covered these aspects in your study? Your study is correct. I'm not doubting your study, but have you considered these factors or not? Or in future you are planning to consider these factors?
Right now, we didn't consider that, but in future, we'll try to do according to that. Consider it.
Okay. Okay. Thank you.
Thank you.
If anyone in the audience has any questions, you may kindly unmute yourselves. All right, thank you so much. That was the final paper presented. I would like to thank each paper presenter who presented their paper on their hard work. It was really a fruitful experience. I would now request Dr. Nidhi Gaur to present Dr. Aman Kataria a certificate as a token of our appreciation for being the session chair. Thank you so much, sir. Your presence really lifted the entire session's experience.
Thank you.
Thank you, sir, for being part of the session. We are just sharing the certificate. So we'll be mailing you the certificate. In the mail, you just presented it here. And thank you so much for being here and sharing. Now, with your permission, may we close the session?
Sure, ma'am. Sure.
Thank you, sir.
Paper presenters, your certificates will be sent to you through email. Thank you for your valuable contributions.
Next week.
In next week. I would now like
expect by the end of the week, end of the next week.
I would now like Dr. Aman Kataria's permission to close the session.
Sure, ma'am. Sure.
Excuse me?
Yes, ma'am.
Do the registered authors also do get the certificates or only the presented ones?
So only the presenters.
Okay, thank you.
It's been a privilege to have you all today and make this session a success. We thank you, Dr. Aman Kataria, once again to take some time out of your valuable schedule and be a part of SPIN 2025.
You're welcome, ma'am.
Thank you all for being a part of SPIN 2025. We will resume the next session at 2 p.m. Thank you.
A very good afternoon to one and all. I, Weber Bhandari, on behalf of the Department of Electronics and Communication Engineering, MIT School of Engineering and Technology, MIT University, Uttar Pradesh, feel honored to welcome you all on the second day of the 12th International Signal and Processing and Integrated Network Conference, SPIN 2025. I also wish to extend a warm welcome to all the delegates and the paper presenters present here. It's a great privilege to have Dr. Smriti Agarwal with us today. I would like to invite Dr. Anil Kumar Shukla to present sapling to Dr. Smriti Agarwal.
Thank you so much, madam, for sparing your valuable time for SPIN 2025. Thank you so
Thank
much.
you, sir. Okay. Thank you, sir. It's my pleasure.
A brief introduction about Dr. Smriti Agarwal. Smriti Agarwal is currently working as an assistant professor at Department of Electronics and Communication Engineering at Motilal Nehru National Institute of Technology, MNIT, Allahabad, Prayagraj, India since 2019. She has received her doctoral degree from Indian Institute of Technology, Roorkee, in India, the year 2015. She has also worked at GB Pant Government Engineering College, New Delhi from 2015 to 2019 as an assistant professor ECED. Her research interests include microwave, millimeter wave, and terahertz radar imaging for non-contact target detection and identification, non-invasive material characterization, non-destructive quality monitoring, antenna design, microwave absorbers, and metamaterials. She has published her research work in several reputed international national journals and conferences. She is the recipient of CSIR Golden Jubilee Research Intern Fellowship from CSIR India in year 2004 and Women's Scientist Fellowship from DST India in 2011. She got the Young Scientist Award from Uttarakhand State Council for Science and Technology UCOST in 2015. She has been serving as technical reviewer of various leading international publishers. She has been elevated to IEEE senior member grade for her research contributions in the year 2021. Welcome once again, ma'am. Ma'am, would you like to
Thank you
call
very much.
would you like to call upon the paper presenter or would you prefer if I did it?
Uh, you did it. You call the paper presenter.
So I would I would like to call the paper presenter with paper ID 503 present their paper. Paper ID 503.
Okay, so am I audible?
Yeah, sure. Can I see your identification proof?
Yeah. Wait, just a second. Is my camera visible?
Yeah, you are visible.
Okay, can you see my ID clearly?
Just wait a minute. Can you please put it back a bit?
Okay.
Yeah.
Is it okay?
Yeah, done. Before you conclude, I would like to tell you that the time constraints for your presentation would be 8 to 10 minutes. Okay.
Okay, sure.
You may continue now.
Is my presentation visible? No?
Yeah, sure. Now you can start.
Okay. So, good afternoon, everyone. My name is Jatan Shukla. I am currently pursuing my master's in computer science from NIT Hamilpur. So, today I am going to present my research based on post-harvest loss mitigation and smart storage management using IoT and Azure Digital Chain. And the authors are Jatin, Suvish, and Navin Chauhan. My paper ID is 503. So, basically, talking about the problem statement, basically, like in today's scenario where the countries are being developed, population is increasing very fast, the increase in food production is also required. So agriculture sectors are facing a lot of challenges, which include land, water scarcity, as well as climate change. And there is one more very important challenge, that is basically post-harvest loss, on which our research is totally based on. So, as the fact suggests that over 40% of food losses are occurring just because of post-harvest. So, post-harvest loss is basically after the crop production is done, when the crops are being stored at somewhere. So, at that place, the harvested crops are being lost due to some qualitative uh, aspect, like in reduction in their weight, or quality is being lost. So, to address these issues, several solutions are being proposed, which includes even some include IoT, some include digital twin. Digital twin is a technology that is being introduced recently in the agriculture field. So, what our research is basically, we are leveraging both of these technologies. So, we are developing an intelligent monitoring system that is basically going to minimize these losses so that we can enhance the food quality, security, as well as we can reduce the resource usage. Okay, so currently, what are the challenges that are being faced? Like as I've discussed, that demand is increased, food production is required, as the fact says that by 2050, the population is going to be 9.7 billion. That's a big data. So it requires 70% increase in food production. So if these types of crop challenges like post harvest losses is occurring continuously, then it will be difficult for us to sustain. And the second challenge is like food security is also related to the post harvest losses. And the last point that I have already discussed, that 40% of losses are occurring just because of. So these are the basically challenges which we are going to solve and encounter in basically researching. So what we are going to do, that we are leveraging IoT, that is Internet of Thing, and digital twin technology. So I'll just give a brief of what is digital twin technology. So it is basically, we are creating a digital replica of any physical object. Let's say it's even a pen. So we are creating a digital replica of it in a virtual environment, and there will be bidirectional communication between physical object as well as the virtual, so that uh, a clear picture of what is the physical object can be shown at somewhere at any distant and remote place also. Exact the same figure. So what we are going to do exactly, that we have taken it to the three steps. First is like we will be collecting real-time data collection. How it is going to be done? So we have got some sensor that will be deployed in the environment where the crops is being stored, and we will collect the data. In our case, we are basically focusing on a particular onion storage. So we will be collecting temperature, humidity, and gas concentration that is basically required to know that whether our onion is going toward the spoilage, or is it okay for the consumption of the humans. And then we will move on to the predictive analysis. So whatever the data we will get from the sensors, we will use it to predict the spoilage risk, and we can enable the proactive intervention so that in future what is going to be happen, we can predict it in nearby future, which will be incorporated by the machine learning process that I will discuss later. And after that, whatever the data we get, on the basis of that, we will create some alerts, like the storage condition of our crop, it's okay for sustaining or for the storage. So if it is okay, then we will not be imposing any alerts. Otherwise, alerts will be given timely to the users, so to the owners. So this is basically a block diagram that how the research will be worked. So as you can see, this is the anisotroper that we are using, and we have got some sensors. This is DHT11 temperature and humidity sensors. We have got the gas sensors. We will be converting the gas sensor data to analog to digital, so that the Raspberry Pi, what that single board computer that we are using currently for this whole process, which is acting as a central unit. So all these data will be sent to this Raspberry Pi, which will send all the data to stored in Azure IT Hub, and after that Azure IoT Center Lab, and these are the several apps of Microsoft Azure software that we are going to use. So leveraging all these services, we will real time monitor the conditions as well as we will impose the alert mechanism. So talking about the system architecture and basically in the hardware, the two primary things that we are using, that is first is the Raspberry Pi, and second one are the sensors. So the Raspberry Pi, as I said earlier, that is a central hub which will collect and process all the data and send it to the Azure to store it. And we have got sensors. In sensors, we have got the ST11, which will be monitoring temperature and humidity. We have got MQ135 gas sensor, which will detect gas concentration. This is basically a hardware architecture. As you can see, this is the Raspberry Pi. We have connected the ST11 sensor. We have connected gas sensor, and this is the analog to digital converter that is basically used to convert this sensor signals to analog to digital, so that Raspberry Pi can understand whatever the data is sent to the Raspberry. Okay, and in software part, we are using Microsoft Azure. These are the one of the most important services that we are using almost 7 to 8 services. There are tons of services that Microsoft Azure provides. These are the four most important ones. So I have discussed only those. So distributing services, as I've told you earlier, that it will create a virtual environment for the same storage area, and it will also help us in real-time monitoring. IoT Hub, it will act as bidirectional communication between sensors and the Raspberry Pi and the cloud. And the IoT Center Lab, it acts as a user-friendly interface between the devices and the sensors. And blob storage will, as the name suggests, will collect the data. So how real-time monitoring will be done? So first of all, sensors will collect the data environment and they will send it to Raspberry Pi. Then that data is going to be formatted in JSON format, and it will be sent from the Raspberry Pi to Azure IoT Hub. From there, we will store that data. We will compare the data with the threshold values, whether it is okay for the crop or not. If it is not, then we will automate the alerts. And for the alerts, we are using a Logic app, which is of Microsoft Azure. And we can send emails as well as we can send SMS, we can send notification based on our priorities. So we are sending temperature and humidity alerts, we are sending gas concentration alerts, and at the end, if it is not beyond our, if it is beyond our threshold, it will send the alerts. As I discussed, SMS, email, and the notifications. So for my research, I have incorporated two of them: email alerts and the push notification. So I have used an IoT app that is called IoT Plug and Play. So the owner of farmers can install that app on their phone, and they will get a notification of spoilage or if any occurs. So mobile phone notification also helps us in expanding our networks. Also, it is more feasible. So some of the advantages, like it is also low cost. Everyone owns it, so there is no extra cost required, and it also eliminates the need of any additional hardware that is required for data collection. And we can also use it for backup as well as redundancy is added also. And it also enables farmers, like every farmer can use their mobile phone as temporary IoT device, so they can monitor their device, their crops, and get it done. Talk
Jatin,
on the future direction that we are trying to incorporate in future, in near future,
Jatin Shukla.
like we will be
Jatin,
incorporating. Yes, ma'am.
Already I think 10 minutes have passed.
Yes, ma'am.
Your time for presentation is 8 to 10 minutes.
Okay. Okay.
So just wind up and come to your result. Have you shown it? You haven't shown any result. Okay, you haven't shown any result.
Yes, sir. No, ma'am, it's basically an implementation basis. So we have some future direction. We are implemented it. There is no
First
such
complete it.
result
First
happen.
complete.
Like we will be just getting. It's completed. That's done. Like we have towards the smart agriculture system. Thank you. These are some of the references. If any questions, most welcome.
So, Jatin, I am audible?
Yes, I'm audible.
Okay. So, my question is this is the post harvest you have developed a system. So, it is just an idea, or you have developed anything? You have connected hardware, then taken the reading or something, or
Yes,
it is just an idea?
and we have implemented it from tip to everything.
But you haven't shown any hardware or anything? Or any data? You haven't shown any data or anything?
And like
Why?
I have incorporated a picture, and that is basically very large data I have
No,
discussed
no.
in
This
the
is the
paper, but
no.
it
This is
might
not
take
the hardware.
very time, so that's why I did.
Listen, Jatin. This is not the hardware. This is the CAT tool from where you have made that actual hardware. You should
Yes, sir.
put the photograph of actual hardware. Do you have that?
I have that, but it's not in the. I don't have a photo of it in the laptop right now.
No, no.
But
This is not
we
the
are.
right way. No, this is not the right way of presentation. You should include, if you are having the hardware, so you should include that photograph and also any of the result. You have taken any result, so you just mention the key result. Okay, few of the result you should mention, so in order to ensure that you have actually performed the thing or not, or actually this is working or not. Okay,
Yes, ma'am. Yes, ma'am.
take it as a feedback only.
Yes, ma'am. Actually, ma'am, I have incorporated in the paper, conference paper, but it was very lengthy, so that's why I didn't include it in the presentation.
Okay, anyhow, you should include some results. You haven't mentioned any of the result.
Yes.
Okay, this all from my side. Anyone else want to ask question can ask.
If anyone in the audience has any questions, you may kindly unmute yourself. So I guess no one in the audience would ask any question. Now, may I call ID number 515 to present their paper?
Yes, hello.
ID number 515.
Hello, am I audible?
Yes, yes, you are audible. Can I see your identification proof?
Just a second.
Uh, just wait. Okay, okay, thank you. As you already know the time constraints of 8 to 10 minutes of a presentation, I hope you
Yes.
will cooperate. You may now proceed.
Yeah, is the screen visible? Just a second. Yeah. So, good afternoon, everyone. I'm Dinesh Reddy. I'm here today to present a project titled Cloud-Based Image Processing and Image Augmentation, which has been accepted for the 12th International Conference of Signal Processing and Integrated Networks. And I am joined by my team members, Sai Kumar, Sai Jeshwant, Shashank Reddy, and Dr. Beena B. Yeah. So let's dive into the details of our project. Coming to the introduction, our project focus on leveraging cloud computing and scalable and efficient image processing. Cloud computing allows us to provide on-demand access to storage and computing power, which is significantly reduces the dependency on local resources. We have used AWS
Sorry to
services
interrupt you,
such
Dinesh,
as
but your camera is off.
oh yeah.
Yeah. You
Yeah,
can continue.
so so we have implemented AWS services such as Amazon S3, Amazon Lambda, and AWS Recognition, which is a cognitive service to automate image management tasks like categorization and processing. Additionally, we have implemented image augmentation techniques using OpenCV and Pillow to enhance the image quality, which is crucial for AI and machine learning applications.
So coming to the problem statement, the traditional image processing methods required high computational power and manual effort, which can be inefficient and time consuming. So our existing systems also struggle with real-time image categorization, making it difficult to sort and manage images effectively. To address these challenges, we have identified the need of a scalable and cost-effective and automated cloud-based solution to handle image processing tasks efficiently. So our project has four main objectives. The first one is to develop a cloud-based image storage and processing system to handle large volumes of images. And the second one is to automate image categorization, which uses AWS recognition to reduce manual intervention. And the third one is to enable real-time image augmentation using AWS Lambda to enhance image quality on the fly. And the fourth one is to improve accessibility and efficiency for the image processing task by leveraging cloud services. Yeah. So the methodology and workflow of image processing. The workflow of our image processing involves two main steps. One is where the user uploads the image and the image will be uploaded in the S3 bucket. Whenever the image is uploaded in the S3 bucket, there will be a Lambda service, Lambda function code, which has been kept to trigger to the Amazon S3 bucket, so that whenever a user uploads an image, it triggers the Lambda function, and the Lambda function code is of AWS recognition. Like whenever a user uploads an image, the code will trigger the Lambda function. The Lambda function will be having the Amazon recognition. These recognition will identify the person's face, and if the person is there, like if the person is new, it will create a new folder, or else if the person is existing, it will add the photo to the existing folder of his. And the workflow of image augmentation is the image upload of our augmentation. User uploads an image in Amazon S3 bucket. This is bucket 2, which again triggers an AWS function. Processing and augmentation. The Lambda function applies various transformation using Python libraries like OpenCV and Pillow. These transformations include resizing, cropping, rotation, brightness, and etc. Based on the user requirement. And after the augmentation, it will show the augmented image there, and it'll give the users two options, whether to download it or move it to the gallery. And this is the flow chart where if a user uploads the image into the S3 and it triggers the Lambda function. After the Lambda function uses recognition for the face recognition. If match found, yes, it moves the image to an existing folder. If no, the Lambda, it will create a new face index for the person, and it will create a new folder. It will create a new folder and move the image to the correct folder in the S3 bucket. And the second flowchart is for the image augmentation. When a user uploads the image, the S3 event triggers the Lambda function, and the Lambda function processes the images for the image augmentations according to the user requirements, and then it will store the image in S3 bucket and verify the image using head object. And here the dashboard, it shows the upload page where the person will choose the file and click on upload. Later, the user can watch the image in the image gallery page, and this is the image gallery page. Later, there'll be separate dashboard where where this is called persons, where you can see the faces of all the persons here. And when you click on a person, you will be able to see what all photos are there on his folder. And this is the augmented page where here the user uploads the photo here, and he'll be entering his desired inputs here. For rotation angle, it is like the degrees. You need to mention the degrees. For flipping the image, it will be menu bar to right flip or left flip, and here it will be the compression quality and etc. And this is the final output of the image augmentation, where the user entered 45 degrees here and the image rotated 45 degrees. And after here down below, we can see two two buttons called download image and move to gallery. Download image, basically you'll be downloading the image into your local system, and if you click on move to gallery, the image will be moving into the gallery direct, which is again triggered by the Amazon Lambda service. And this person, if it is a new photo, it'll be created a new folder, or else it'll be if there is an existing folder, it will be added to the existing folder. And implementation, the face recognizing process, we have used Lambda function, checks for matching faces in the recognition collection. If it is matched, the image is stored in corresponding folder. If there is no match, it will move to a new folder. And the image augmentation process, here we have used specified transposing like resizing, rotation, brightness adjustments, and etc. Where the Lambda function process the imaging uses OpenCV and Pillow. Coming to the result. Yes, ma'am.
Sorry to interrupt, but can you wrap up because your time is expiring?
Yes, yes. Coming to the result, here we have successfully categorized all the images into the person's folders on their accurate face detection, and the image augmentation is also works excellent, and the scalability and coming to scalability, it is efficient of increasing user uploads and augmentation with AWS Lambda. Coming to the future scope, there is a lot of enhancements in this project, where this project can be used in wedding photography, where the photographer will be clicking all these photos, and there'll be a separate dashboard. Like if a user just scans his face, it'll capture the face and it'll directly show his all images. And also by using advanced ML's model, we could also improve the face recognition and automation. Conclusion, I would like to conclude that our project-based image processing, like cloud-based image processing system, enhances automation and scalability, making image management more efficient by leveraging AWS recognition and Lambda. We have streamlined face recognition and augmentation process. This system provides a robust solution for image management with minimal manual intervention. And that's it. Thank you for your attention. I'd be happy to take any questions you may have.
Yes, Dinesh.
Yes.
My question is, in this you have shown face recognition, face recognition,
Yes.
face matching, and after that
Yes,
image
yes.
augmentation. So
Yes.
you haven't shown anything like how much accuracy you are getting. What is there may be certain error also in getting the result.
Yes, ma'am.
So what are that? How much accuracy you have achieved?
Actually, ma'am, in low light and low light areas, and if there is some blurriness in faces, we have found that there is some the code is not sorting the persons properly. Well, in good light and all, it is sorting it properly.
So you do not know what is the accuracy level. Have you got the
Ma'am,
data? What is the
no, ma'am.
accuracy?
Yeah.
How much pictures
So
you have
while
taken?
we saw the Amazon console, which it will be connected to the AWS Lambda function in the Amazon collection, in the Amazon console, we can see for a photo it is showing 95.6, ma'am. Accurate.
Okay. So
in
there are
identifying
certain
the person.
okay, there are certain results like confusion matrix or something. You should mention that. Okay.
Yes, ma'am.
In order to support your findings.
Yes, ma'am. Yes, ma'am.
Or one more question, can you tell me now what is the application of this augmentation, image augmentation? What is any practical application?
There is no practical application. Like if a user, if he just in the normal websites, ma'am, if you see online, there'll be drive. Some drives may have image sorting, but most of the drives will not have image augmentation. So
no,
our
but
project.
if you are if you are saying there is no application of image augmentation, then what is the use of doing it?
I didn't get you, ma'am.
If there is no application of image augmentation that you are proposing, then what is the purpose of doing this or getting this?
Yes, ma'am. Where for myself, I have experience during my after my inter examinations, where I wanted to post my photo, like not posting, like I wanted to just submit my photo in an application where it is given that the image should be less than 1 MB or something like that. So then I need to go to a third party service, in website itself I need to refer to a third party website and upload my image, and then I need to like compress it, than going to a third party where our images store, like our images store are in this drive, right? So here itself we can have this special what you call feature where we can, our data is safe and we can compress it right itself from the gallery.
Okay. Okay, fine. Fine, Dinesh. This all from my side. Thank you.
Yes. Anyone in the audience have any questions? You may kindly unmute yourself. Okay, so no one's there. Now I would like to call paper presenter paper ID 557. Paper ID 557, present their paper.
Yes, sir. I am audible.
Yeah. Can we see your identification proof, please?
Yes.
Just a minute. Yeah, sure. Done. Before we proceed, the time constraints are 8 to 10 minutes as usual. Now, you can start.
Okay, sir. Sir, anyone other is sharing their screen? I can't start the screen sharing.
Can you try again, please?
Okay, ma'am. Good wishes to everyone. I am Diksha Gupta, a final year computer science student at Kalgodias University, and I I am pleased to present our research on a decentralized voting system based on blockchain. I'm excited to share how blockchain technology can transfer this future of electronic voting. And the author of this presentation of this research paper was Dr. Santosh Kumar, and I am Diksha Gupta and Tushar Yadav, and presented by myself. Let's start. Elections allows people to choose their leaders. Traditionally, voting was done with paper ballots. Later, EVMs are introducing, but they often face security issues, fraud, and lack of transparency. So, a blockchain voting system that makes elections tamper-proof, secure, and transparent. Let's first understand the problem with the existing current voting system. The biggest problem with the existing voting system was is the lack of security and transparency. For example, in many countries, people worry that elections are rigged or votes are changed without their knowledge. To solve this, we need a system that is safe, transparent, and trustworthy. To tackle these issues, our research aims to develop a decentralized voting system which following with key objectives. First one, prevent voting fraud by ensuring votes are immutable and verifiable. Second one, eliminate long queues by enabling remote voting from anywhere. And third one was reduce election costs by minimizing paper-based voting logic. Fourth one was enhancing transparency and anonymity so voters can verify their votes while maintaining privacy. Now let's see what other researchers have done in this field. Many researchers have tried using blockchain for voting. For example, first one that was Cruz created a Bitcoin-based voting system, but it is too much. But it is used too much energy. McCory made a blockchain voting system, but it was still vulnerable to attacks. And third one, Boschri proposed a Ethereum-based biometric verification for voting voters without smartphones using chain-based ring signatures. And
Uh, Also, a researcher that was Khan created a voting system using MetaMask, but it exposed some ballot data. While these were good attempts, they still had problems with security, privacy, or efficiency. Our system improves upon these, offering better security, transparency, and ease of use. Let's see how it works. And our proposed system for our research that was key. Our voting system is built using blockchain, smart contracts, and secure authentication. And we have used uh, some frameworks. That was first one is truffle framework that is used for developing smart contracts, and we use ganache, our local blockchain simulator, for testing. And third one, we use also metamask, a crypto wallet for authentication. And users need to have some ether or ethereum money in order to create an account with an wallet address. So that was the proposed system where where voter has to initiate their vote, and with using some devices for voting, and there was a voting platform. There was encryption or decryption, then they were vote using blockchain. Next, here is how it works. The working of this voting system. First one, voter login using MetaMask, which connects to a local blockchain. Then they select a candidate and submit their votes. Third, then next step is a MetaMask transaction verifies the vote, ensuring transparency. Smart contracts prevent double voting by verifying their voter identities. Next step, votes are stored securely on blockchain, making them immutable and verifiable. So that was the working flow of the decentralized voting system based on blockchain that I am using in my project. The system ensures tamper-proof elections, real-time transparency, and voter anonymity. Now let's take a look at the algorithm behind this process. I am using some algorithms that in the using blockchain algorithm that guarantees that the system was immutable transaction. Once a vote is recorded, it cannot be changed. Second one, we use smart contract execution where every voter is verified before casting a vote. Third one, decentralization. No central authority can manipulate votes. These steps ensure that the voting process remains fair, transparent, and secure. And these are the algorithms that we use first for contract deployment. First, I am initializing contract if I have to add candidate, then here I am using only three candidates, John, Vic, Ye. These are the names. If I want some other candidate, then I can add. Now one private function for add candidate, this was the function algorithm. Next, for the cast vote, this was the function vote candidate, update vote, record vote. Now let's move to the results. We compared our decentralized voting system with conventional e-voting methods. The results showed higher security. No centralized over means no single point of failure. Second one is better transparency. Every vote is recorded on the blockchain, preventing fraud. Third, improved voter privacy. Votes remain anonymous while being verifiable. Here is a comparative analysis table for demonstrating the benefits of our system over traditional e-voting system. Here are the table for analysis of our voting system. It was 99.9% immutable transaction, 92% for truffle framework or MetaMask. It was anonymous voting for, and to some that was the result of our project. It was the preview of the result on the main page where the votes are displayed on that. Now, to summarize, our research introduces a secure, transparent, and decentralized blockchain based voting system. The key takeaways are smart contracts prevent vote tampering, blockchain ensures transparency and security, MetaMask and Ganache enable seamless voter authentication. For future improvements, we propose facial recognition integration to prevent duplicate votes, and also we use two factor authentication for added security and scalability enhancement to support nationwide elections. With these improvements, blockchain voting can become the future of safe and fair elections. And here are some references from I have been reviewed our research. Thank you for your attention. I would be happy to answer any questions you may have.
Yes, okay, Diksha.
Yes.
I want to ask whether this technique has been implemented by any other literature also.
Yes, ma'am. I and my teammates both have worked on that project.
So you haven't shown a comparison with that results, how much accuracy or what they have achieved as compared to your work.
Ma'am, I've achieved that it was 99.99.9% for immutable transaction, that once anyone got vote, no other can vote for their ID.
How your result is different from the earlier literature? My question is.
Ma'am, earlier literature where some other earlier जो researchers हैं, that there some privacy was not there and some transparency was not there. If
Okay, you should give a summary or you should give a comparative table, okay, in the presentation comparing your result with the previous available literature. Okay, Diksha. Okay, fine.
Okay, ma'am.
Okay, nice presentation.
Thank you, ma'am.
If anyone in the audience has any questions, you may kindly unmute yourself. So now I would like to call the next paper presenter, paper ID 573, to present their paper.
Hello, sir. Am I audible?
Yeah, yes, ma'am.
My name is Gayatri More and my paper ID is 573.
Yes, ma'am.
I'm just sharing. Yes.
Yeah.
Sir, I am a PhD candidate and yet my ID has not been generated. So, is it okay if I show you my Aadhaar?
Yeah, it's fine.
Just a second. I'll just first share the screen and then I will just. Okay. I hope my screen is visible and this is my ID.
Just a moment, please. You may proceed, ma'am. Time constraint are as usual 10 minutes. I hope you copy.
Sir. Thank you. Yes, sir. Just tell me if my screen is visible or not.
Yes, your screen is visible, ma'am.
Okay. So to start with all the presentation, myself Gayatri More. I'm a PhD candidate and my guide name, I'm doing my PhD under the guidance of Dr. Otkar ma'am. She is my co-author with this paper. My topic is, I'll be presenting the paper, which is mitigation of bus errors in multipath transmission. Multipath wireless networks.
Please make it in slide mode. Actually, no? It's,
yes, I tried. Yes, actually, I tried, but yes, okay, it's there.
Yes, it is there.
Okay, thank you. So let's start the introduction. This will be the index. Well, about I am going to follow throughout the presentation. First, I'll give the introduction to the vehicular networks and 6G networks, basically in the 6G area. I have done some literature review where I've made some gap identification, then the methodology based on those findings, then simulation steps which we have followed to get the results, and then finally conclusion. So to start with the introduction of the topic, we'll first see how 6G networks are very important in our future wireless networks. So it is a very important constraint where if we need to adapt to the complex heterogeneous networks which are there in the next future. So 6G allows us to work with all the problems with the future wireless networks. We could get stable and reliable transmission over the multi-part transmission schemes. We can get secure communication. We can have a seamless data transfer over the network. So these are the trends of 6G networks. So, a wireless network as a backbone of modern communication, it enables seamless communication and data transmission and secure and stable communication over the network. There are a few challenges when we cope up with when we think about 6G networks. So, those challenges are basically burst errors are the limitation which I have chosen for my further research. So burst error is very significant parameter which degrades the communication quality. And the application area you can say which we have chosen is vehicular communication. So vehicular 6G networks which basically has key features of multiple transmission which can have AI driven optimization. You have must have seen this in IoT. Ultra low latency, it should have more bandwidth utilization, it should do. So these are the key features of vehicular 6G networks. So there are challenges which hampers the benefits of high reliability, low latency, and high throughput. So those challenges are frequent handovers between the peers, interference and congestions, and burst errors. So burst errors in packets. We are talking about the packets in networks. So burst error in networks in terms of packets in vehicular networks have some basic understanding. So what causes the burst errors in vehicular networks? It may be caused by channel fading, it may be caused by interference, and it may be caused by congestion and mobility of the vehicle. So this hampers the throughput, decoding failure ratio. You can say it hampers the security and stability. So to target this fact, we have one approach, that is network coding approach. Network coding is basically what I'll tell you in short. Network coding is basically what in the network we have intermediate nodes, right? A sender is there, or a start node where you are starting the communication, and the end node where you will be receiving the packets. So intermediate nodes are there in network coding. We firstly schedule the packet using path scheduler, but here in network coding we blindly just sending the packet to the next node. We are collecting the packet at the intermediate node. We are applying some algorithm, algebraic or some coding there actually, basically, and then we forward it to the next packet, sorry, next node. So that is what the idea of network coding. There are types of network coding. One is linear network coding, random network coding, and non-linear network coding. And very in this application area, this network coding shows increased throughput, reliability, reduced delay, and security benefits. So that is why we have chosen to target this fact of burst error in vehicular 6G networks. We have come up with the network coding scheme. So to study this further, there are these many papers we have studied to get the idea about basic network coding, conventional network coding, and what is we come up with is six skip network coding, that is SNC. So first paper we have studied is vehicular communication area. That paper area is vehicular communication. It has reliable environment to improve the burst error multipath transmission. Improves it have theoretically explained the skip network coding, which we have later experimented on and validated with the experiment simulation, we can say. It's not experimental, simulation kind of things. So these are all the references. I'll not go into details with all the references, but these are the gaps we have identified Physical network coding significantly improves throughput, reliability, and security on the various wireless network applications. SNC provides superior performance that I already told you. It reduces the packet reordering, which hampers the bandwidth utilization. So existing methods were BNNC, that is Big Num network coding, and one is EDPF, which was earlier delivering path first technique. So these two were there. As we have simulated SNC, BNNC, and EDPF. We have compared SNC, that is skip network coding, with BNNC and EDPF, which were previously implemented coding techniques. So what is basically skip network coding? That is SNC. Here I'll tell you in short. So what traditionally we do, we encode the packets and we discrete them over the network, right? Discretely send the packets over the path multipath transmission. But in SNC, what they do, they use the pre-interleaver before. Okay, they use interleaving techniques first and then discretely send the packets over the multipath. So in simulation we have think of vehicular communication basically, but in vehicular communication we have chosen the point to point communication, or you can say two modules we have designed. One is aggregated module and the second is mobile module. At the sender's end is there, that is mobile module is there, and at receiver's end AM module is there, that is integrated module. So these are you can say abstracted packet transmission process in vehicular communication into point to point transmission process, but not in single path. We have considered multiple senders and multiple receivers, so multi-path transmission in that way. So firstly, we aggregate module is used, then design the aggregation module, that is AM module, then simulated those three communication paths we have simulated, then introduced burst error
Excuse me, ma'am.
in first. Yes.
Can you wrap up quickly because your time is exceeding?
Yes. So I'll not go into detailed simulation steps, but I'll show you my results. Okay. Performance matrices, three performance matrices we have chosen. First is decoding failure ratio, second is throughput analysis, and third parameter is what? It is again throughput, but we have compared three multipaths. So we have just introduced error in path 1 and compared it with other two paths. So these were performance matrices we have evaluated for our research. So first is decoding failure ratio. As the graph shown, blue dots are normal conventional network coding, and the orange dots are basically the skip network coding. As graph shown, at the lower level, SNC is stable. Okay, and as average length of burst errors though increases, those three graphs is basically where we have introduced average loss of 1%. At the middle image we have introduced average loss of 5%, and at the last we have introduced average loss of 10%. So here you can see in every graph in all the three images, SNC shows the stable decoding failure ratio. Higher the decoding failure ratio, that means more retransmission occurs, and the lower bandwidth utilization occurs. So to avoid that, SSC is better one. This is the tabular format of comparison. Then these are the three graphs where we have analyzed the throughput. Okay, so we have implemented SNC, BNNC, and EDPF. The BNNC and EDPF were the previously implemented techniques. New is SNC. So as first is SNC, first image is of SNC. If you compare all these three, initially you can see they all the growth is same. You can see the growth is same, but later when the peak value, that is 15, peak value is the 15 Mbps is what the peak value. When peak value happens, SNC performs, some jitter is there, but SNC performs.
Excuse me, ma'am.
Yes.
Ma'am, your time limit is over. Can you wrap up quickly?
Okay. So this graph shows that SNC has better throughput. Then this is the tabular format of what we have compared previously with the images. Here three paths are considered. where first path has the burst error. And as the graph shows, SNC shows better throughput analysis over all the three paths. Conclusion that SNC, of course, and without a doubt, SNC outperforms the BNNC and EDPF, which were the previously implemented techniques. It gives you higher throughput at the peak value of 7.55 Mbps. It has lower decoding failure ratio, and lower decoding failure ratio means probability of packet group loss is less. It has better stability over the network, over the multi-part transmission, and it is a strong candidate of 5G vehicular networks. These are the references which we have considered to come up with all this simulation. Thank you. I would like to have your questions if you any are there.
Yeah, I have no questions. So if anyone
Yes,
has, I have no questions. It was nice presentation, but you should keep track of your time also. Okay.
Yes, ma'am. Yes, ma'am. Sorry.
Anyone in audience want to ask question? Can please ask.
That was the final paper presenter. I would like to thank each paper presenter who presented their paper on their hard work. It was really a fruitful experience. I would now request
you.
Dr. Anil Kumar Shukla to present Dr. Smriti Agarwal a certificate as a token of our appreciation for being the session chair. Thank you so much, ma'am. Your presence really lifted the entire session's experience.
Thank you so much again, madam, for joining SPIN 2025. Hope we have to see you in next SPIN also. Thank you so much once again.
Thank you, sir. Thank you for the invitation, and hopefully next year I will be there in person. Thank you.
Thank you.
Paper
Thanks to
presenters.
all paper presenters. It was nice presentation from all of you.
Paper presenters. Your certificates will be sent to you via email shortly. Thank you for your valuable contribution. I would now like Dr. Smriti Agarwal's permission to close the session. It's been a privilege to have you all today and make the session a success. We thank you, Dr. Smriti Agarwal, once again to take some time out of your valuable schedule and be a part of SPIN 2025. Thank you for being a part of SPIN 2025. Thank you, ma'am.
Thank you. We can conclude the session, I think, and end the meeting.